Hi there! Today I'm going to be showing you how to recreate the classic card game Solitaire using the Phaser 3 framework. And so in this video, we'll be building this game that you see here on your screen now. And so the game of Solitaire is a fun, classic single-player card game that involves strategy, patience, and sometimes a bit of luck. The card game involves arranging cards in specific order based on the suit and rank of the card, and the goal is to move all of the cards from the tableau or the main playing area up into what is called the foundation piles, the 4 piles at the top of the screen, each starting with the ace and then building up in ascending order to the king of the same suit. And so one thing to note is there are a variety of solitaire type games, and those type of games are generally played with one or more standard 250 card decks. And so for this tutorial, we'll be focusing on one instance of the game Solitaire that it uses a single deck of 52 cards. And so before we dive further into the tutorial, one of the things you might be wondering is why Solitaire for a tutorial series, and why might you be interested in this? So in order to actually create the game of Solitaire with the Phaser 3 framework, I had to actually use a number of different game object types and built-in methods of the Phaser 3 framework that are not always used in many of the popular tutorials. And so due to this, I thought this would make a good tutorial series to go ahead and share with others. So while building the game of Solitaire, you'll get to see how we can use the following features of Phaser 3 to create our game. The first one is what is called a zone game object. And basically what the zone game object is, this is an invisible object that's in your scene that we can interact with. And so when we're drawing cards from our draw pile, we're not actually clicking on the image game object, we're actually clicking on what's called that zone. And so in addition to this, we'll take a look at how we can use drag events on our game objects to actually move objects around our scene as we drag our cards between our various piles. So on the topic of zones, we're also going to be taking a look at what's called a drop zone, and we'll be checking for when game objects are dropped into our various zones. And so when we have our cards drop between our various card piles here, we have a drop zone there that allows us to listen for when a game object is entering that zone. And so by using the drop events, this allows us to check for overlaps between our objects without actually having to rely on physics. We'll also be taking a look at our data manager for how we can store and retrieve data on our game objects. And so then that way for each of our cards, we can store data of like what pile it's tied to. So then that way we move it to another pile, can perform our internal logic for Solitaire. We'll also be taking a look at things like containers and how we can use those to group our game objects. So instead of specifying our X and Y values for all of our cards, we have one container for a pile. And then that way we only have to specify our X value for the container itself. We'll also be taking a look how we can use the built-in scene transition events. So then that we get this really nice transition between our title scene and our game scene. Finally, we'll also be taking a look at things like sprite sheets, images, and how we can display these in our games as game objects. And so for this tutorial series, we'll be building the game in TypeScript. So one of the requirements is you will need to have Node.js installed locally on your computer or have access to a development environment that has Node.js installed. We'll be using Node.js version 20, so you should be able to follow along with that, at least that version or later. Earlier versions may work, but it's recommended to at least be on version 20. For Phaser 3, we'll be using the library version 3.80. Earlier versions may work, but for this project, that's what we'll be using for this game. All right, and so for this tutorial series, there's going to be 6 main parts. So for our first part, we'll be focused on doing our actual project setup. So they'll be grabbing our initial files, installing our dependencies, and then going ahead and running the project locally. Next, we're going to go ahead and take a look at our game layout. So we're going to focus on the UI of our game. And so we're going to start building out our various card piles, like our tableau piles, our draw pile, discard pile, things like that. Then we'll go ahead and transition over to our player input. And so this is where we're going to start listening for like our click events for our draw pile. We'll create our card drop zones, and then we'll listen for drag events so we can move our cards around. All right, so then next what we'll do is we'll start building out our actual library logic for the game of Solitaire, and so we'll have that completely isolated from our Phaser code, so it'll be reusable. We'll then go ahead and create an instance of that new class, and we're going to go ahead and tie it into our Phaser game, and then that way it's all connected together. Then finally, we're going to go ahead and wrap up. After we complete our game, we'll go ahead and add a nice title scene. We'll add some minor transitions, and just so it gives that really final feel. All right, so one last thing I want to do before we start diving into a tutorial is I want to go ahead and give a shout out to Ken. So Ken actually is the awesome creator of the assets that we're using in our game. So all of these cards that we see here were created by Ken. And so you can find a link to this awesome creator in the description of this video, as well as in the README of the project files. All right, so before we go ahead and start working on our code, I just want to go ahead and review the game mechanics and the rules of the game of Solitaire. and now we can refer to this later as we're building out our game. So in the game of Solitaire, we're going to start with a standard deck of cards, so 52 cards, where there are 4 suits of cards. There will be the diamonds, the hearts, the spades, and the clubs, and we're going to have an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack, queen, and king. And so these deck of cards are going to be shuffled together and then dealt into the 7 columns that we see here on my screen, which is called the tableau. This is your main gameplay area. And so our first column is going to have 1 card, second column will have 2 cards, 3, 4, 5, 6, and then 7. And when we deal up our cards, all of them will be face down except for the bottom card in the stack, and that one will be face up, and that's the card the player can interact with. And so then you can go ahead and move your cards around the tableau according to very specific rules. And this is primarily where you can place a card of one color onto a card of opposite color in descending order. So as an example, I can move this ace to this 2 here, or this 2 here, because it alternates in color, and this is the next descending card. And so our objective is we want to go ahead and expose our hidden cards here, so that way we can keep moving them around and eventually get them up into our foundation piles. And so to get our cards up to our foundation piles, we have to play our aces first, and then we can start adding cards on top of it until we eventually reveal all of our cards here. And so the game is finally won if we manage to get all of our ace, if we manage to get all 4 of our foundation piles to have ace through king. And so there's 4 different types of card piles in our game. The first is the tableau, so these 7 piles here. Next is our foundation, these 4 piles here, so we have 1 for each suit. Then we have what is called the stock, or our hand, or our draw pile. So this is where we can draw cards that have not been laid out on the table, and now we have access to these. Finally, we have what is called the talent, or the waste, or our discard pile. So that's where cards are placed if we don't actually use them from our draw piles. For our game, we'll draw them, place them right on top of our discard pile, and then what we can do is actually play those cards. And so if we go ahead and keep playing, we should eventually find a card we can play. And so we have this 2 of clubs, we can move it to our foundation. And now we have this 10, and then we can also play that there as well. And so as we play our cards, we'll get access to our cards that are underneath the other ones in our discard pile. All right, so now that we went ahead and reviewed the mechanics and the rules of the game, now we're going to go ahead and start working on our project. And so to get started, what we'll need to do is we're going to need to go ahead and download a starter code template from GitHub. So in the description of this video, there'll be a link to where you can find the starter source code. So on GitHub, there's this tag, this initial project setup here. You can direct download it here, or you can clone the repo and then go ahead and check out this tag, and then you'll have the code for the starting of the project. All right, so you can go ahead and download that now. And so go ahead and pause the video. And once you have your files, go ahead and open them in your IDE of choice. All right, so once we have our project files, if we go ahead and open them up in our IDE, you should see the following project structure. And so for our project, our main entry point for our web application will be our index.html page here. Very simple. We just have a very simple div with a reference to our script, our main.ts file, where we create our Phaser 3 game instance, and we'll have all of our code. Next, we'll have our public folder. So this will have all of the assets that we'll be using in our game. And then under our source folder, this will have all of the code that we're going to write. So right now there is some boilerplate for our Phaser 3 game. So in the main.ts file, we're creating our Phaser 3 game configuration, and then we're going to go ahead and create our new game instance once our window loads. Under our scenes folder, we have a few boilerplate scenes, and so first will be our common file. So this has all of our common code that'll be shared between our project files. Primarily right now, we have a couple const for our scene keys and then our asset keys that we'll be using, as well as some configuration for our cards width and height. Next, we'll have our preload scene, and so this scene will be used for loading in all the assets that we need for our game, so they'll be available later in our title and in our game scene. So for right now, we just have a basic structure for our phaser scene, and the same thing is done for our title scene and our game scene. So one thing to note is our preload scene, title scene will go ahead and transition to the next scene in our order. So we'll start with preload. Once everything's loaded, we'll transition to title. Once our title scene starts, we go right into our game scene. And so that'll be modified later as we're working on our project, but it's just so we have our boilerplate. Finally, in our game scene, all we're going to do is we're going to create a simple hello world text game object just so we make sure everything's working and we can see that on our canvas element. All right, so the rest of our files are mostly configuration files, so it's to support running our game. So we're going to be using Vite for our web dev server and for compiling our TypeScript code into regular JavaScript code. So to go ahead and get started, the first thing we need to do is we need to go ahead and install our project dependencies. And so this is where you'll need to have Node.js installed. And so what we're going to go ahead and do is we're going to go ahead and open up our terminal. All right, and then what we'll want to do is you want to go ahead and run npm install. So what this is going to do is going to use our package.json file to grab our relevant dependencies, and it's going to go ahead and install those locally so we can go ahead and use those. So once that's done, we should then see a new node modules folder where we'll have our project dependencies. You can also run npm ci, and what that's going to do, that's going to use the lock file to also install your dependencies. So once you have those, to actually go ahead and run your project locally, there is a script start that tells Vite to go ahead and start our live dev server, and then we can have our live reload while we're working on our code. So to go ahead and do that, if you do npm run start, what that's going to do is it should start a local server. And so now we should see on port 3000 on our local host, we should be able to view our game instance. And once it loads up, we just see our hello world text, and we know that our Phaser 3 game configuration is working. So if we go ahead and just go right into our developer console, we should see the Phaser banner with our version that we're running. And so we're doing the 3.80. All right, so one of the things I didn't cover when we were discussing our project structure is why we have multiple Phaser 3 scenes. And so in Phaser 3, the framework has this concept of scenes to allow you to break up your game into logical sections or states, and each scene allows you to render out game objects to your HTML canvas element. And so for your Phaser 3 game instance, you'll always at least have one scene instance, but the framework allows you to create as many as you want. And so what we're doing with our project structure here is we're breaking up our various game states into separate Phaser 3 scenes. So as an example, like our preload scene is where we're going to handle loading all of our assets, and that's all it's going to be responsible for. Then our title scene will be representing that scene where we show the player the name of the game, and we say, hey, go ahead and click to go ahead and start. And so this is where we could also do other things like maybe options or have like a credit scene and different things like that. And so the sole purpose of that scene is just to handle all of that logic so it doesn't actually get mingled up with our code for our actual game. And then our game scene, this is where we should have our actual logic for playing our solitaire game. And so by doing this, it makes it a lot easier to maintain our code over time and then actually extend the functionality of our game by creating this project structure. All right, so with our project now set up and running locally, we can go ahead and start working on coding. And so to get started, the first thing we're going to do is we're going to go ahead and load our assets that we'll be using in our game. So then we start creating our game layout. And so to load assets in Phaser 3, we need to go ahead and tell our Phaser 3 loader plugin to go ahead and load on our files. And so to do this, let's jump over to our preload scene, and we're going to jump into our preload method. And so to go ahead and load in our assets, what we'll do is we're going to go ahead and do this. We're going to do load, and this will reference our loader plugin. And now this plugin will give us a number of built-in methods for loading various file types. And so if I want to go ahead and load in an image, as an example, I can use the image method, and then it's going to go ahead and provide me all of the arguments that I need to provide. And so typically when you want to load in an asset, the two primary things that you need to provide are going to be some type of key for that asset. And what that key is used for is this is going to be your cache key. So when Phaser loads in your assets, it's going to do it one time and store it in the cache, and then that way later in your other scenes you can go ahead and reference that data by referencing it from the cache. And so this key is going to be the unique identifier for grabbing a reference to that asset. And so a good example of this is if I was trying to load this image in our preload scene here and load the same image later on in our game scene, Phaser will first check our cache to see if we've already have that cache key, and if so, it won't actually load in that asset. And so this will just allow us to reuse our assets throughout our game. And so for our cache keys, these are just strings. And so what we're going to do is in our common folder, we have this const called asset keys, and we'll be grabbing those from here. And so by storing these in an object, it allows us to reference that same string throughout our project and just going to keep our code a little bit cleaner. And so what I'm going to go ahead and do is I'm going to reference asset keys, and then we're going to go ahead and start right off, and we'll do our title image. And so to go ahead and load in our image after our cache key, the next thing we need to provide is our URL of where we can access our assets. And so for our game, it's going to be under assets, images. And so our public folder, this will get served statically. And so we ignore the keyword public, and it starts using our subfolder. So assets, images, and now under that folder, we're just going to go ahead and use our title.png. And so we're going to have to load in another image. So let's just copy this line of code. We're going to go ahead and paste it. And so we're going to have our click to start image. And so let's go ahead and update our name. So we'll have click to start PNG. And so after those images, the next thing we want to do is we want to go ahead and load in what is a sprite sheet. And so a sprite sheet is just basically an image that's made up of multiple smaller images. And typically we call these frames. And so when we load this into Phaser, if we load it as an image, Phaser is going to just reference this whole thing as one single image. What we want to do is we want to break this down into the actual frames, and that's when we'll go ahead and use the sprite sheet method. What it allows us to do is we can go ahead and tell Phaser how to break up this big image into smaller images, providing the frame width and height of our various frames. And this will make more sense when we'll go ahead and display our card in our game, but that's what we need to do, is we just need to tell Phaser how to actually go ahead and do that. So to go ahead and do our sprite sheet, we're just going to do this.load, and so on our loader plugin, we have a sprite sheet method, and so now we can go ahead and provide our asset key, and so this will be our cache key, and we're just going to do cards. Next, we'll have our URL, and so we'll have assets, we're going to have images, and now we're going to have our cards.png. And now when you load in your various file types, if you ever need to provide additional configuration options, this will generally be like your third argument here. And so for our sprite sheet, this is going to be our frame configuration. And so what we'll do is we'll do our frame width. And what we're going to do is we're going to reference our card width variable from our common file. And then we'll also need to do our frame height. And we're going to do the same thing, but with the card height variable in that same file. All right, so what this is going to do is this is going to tell Phaser to go ahead and load in our assets. And now if we come back to our game, what should happen is we should still see our hello world text. We should not see any errors about trying to load files, but visually nothing's actually changed in our game. And so this will be a good time to go ahead and talk about waiting until our assets are actually loaded. And so one of the things we did here is we used our preload method of our scene to go ahead and load in our assets. And so typically with your game frameworks, what you need to do is loading your assets will take time because it'll happen asynchronously. The framework needs to go ahead, the browser needs to go ahead and download that asset from wherever it's located and grab that raw data so we can do something with it. And so typically we'd want to go ahead and wait until we have all the assets for our game before we start allowing the player to actually play our game. Otherwise, what can happen is we can go ahead and try to create our assets before they're actually loaded, and that's going to result in a broken image in our game. And so an example of what that would look like is in our game, if we try to reference our images before they're ready, we're going to see this square appear in our game, and that's going to be a broken image. And so that can happen in one of two ways. Either A, our asset isn't ready yet, so we don't have it in our cache, and so this will be rendered to our scene. Or when we load in our assets, we provide the wrong URL to our file, so Phaser can't actually download it, and so we'd also have a broken image. And so in order to wait until all these assets are downloaded, what we can do is we can use the preload method in Phaser. And so what this does internally is anytime in this method, if we provide assets we need to load, Phaser is going to queue them up for us, and then it's going to go ahead and start downloading them once the preload method is done running, and it's not actually going to invoke our create method until all these assets are now resolved and loaded. And so if we tried like loading these from our create method, Phaser would not actually do that for us, and we'd actually have to manually resolve our files automatically and then control the wait until we start our next scene. And so one thing to know is with the game framework, the Phaser scenes have these scene lifecycle events that it goes through for every single scene. And so at a high level, typically what this looks like is there's an init method that will initialize your scene first. Preload will also then be invoked so we can load in any of our assets or different things like that for setup. And once the preload method is finished, Phaser will go ahead and invoke the create method for your scenes. And so typically this just happens one after the other, but when we load in our assets like this, Phaser will wait until this is done before it starts our scene. And so by loading in our assets here, we get it out of the box for free. We don't actually have to wait for anything. Phaser will handle that for us. So now that we load in our assets, let's go ahead and test to make sure our assets are actually working how we expect them to in our game. So what we'll do is let's jump into our game scene. And what we'll do is let's go ahead and get rid of our text here for hello world. And what we're going to do is we're going to create what is called an image game object. And so to do this, we're going to do this.add. And what this does, this references the scene game object factory, which has a number of built-in methods for quickly creating new game objects in your scene. And so one of these is going to be the image game object, which is just a basic game object that allows us to render out a texture. So one of the images that we loaded onto our canvas element. And so when we call this method, we need to provide where we want our game object to be positioned in our canvas. And so this is going to be your X and Y values. And so I'm going to go ahead and do 0, 0, and we'll come back to positioning in 1 second. Next, we need to go ahead and provide our texture. And so this needs to match those cache keys that we previously provided in our preload scene. And so what I'm going to do is I'm going to reference cards. And so when we load in our assets, we use that cache key here. And by using that same cache key here, Phaser now knows to go into the cache and grab that relevant texture so we can apply it to our game object. Next, we're going to go ahead and provide a frame. And so typically with your images, you don't have to provide this. It'll be optional. But when you load in images, there's always one default frame, and that'll be 0, and that's the whole image data itself. But with our sprite sheets, this will be a little bit different, and we'll see that in 1 second. Next, we're going to go ahead and set origin, and we're going to go ahead and set this equal to 0. So when we call set origin, we can go ahead and provide our X and Y values, or if we provide one value, Phaser will apply it to both of those. So our origin controls how we place game objects in our scene. And so what I'm going to do is I'm going to go ahead and save and jump back over to our game. And now what we should see is we should see our ace of clubs rendering onto our canvas element. And so what's happening here is when we call this .add.image, first we do our X and Y position. So in your Phaser game. And so for your X and Y coordinates, how this works is in the top left hand corner, this is going to be 0, 0. And as we move to the right, our X value will continue to increase. And as we move down, our Y value will continue to decrease. And so we'll have 0, 0. And then like if we come over here, this will be like 50, 50, and so on and so forth. And so the next thing is for rendering out our image, it pulls that data from our cache. And because this is a sprite sheet, we're only using part of our original image. So for our cards, if you remember, this was this very large image here. We have all of our card images built into this one main image. And because we split this into what we call frames, we can now reference those frames to render out just that subtexture of the whole image. And so as an example, in our code, if we want to go ahead and change this to, let's do 1, what's going to happen is that's going to grab the next frame, so our first frame here from our image, and then we'll see our 2 of clubs. And if we go ahead and change it one more time to 2, we should now see our 3 of clubs. The next thing we did is we referenced our origin. And so when we position our game objects, by default, your origin is in the center of your game object. And that origin is used for various things when we want to move our game object in our scene or rotate it and different things like that. And when Phaser places your game object, it always places it based on that origin. Now, because we said 0, 0, that's going to place our origin in the top left-hand corner. So now when Phaser draws out our game object, our image, it'll position it based on this origin. And so that's where it's going to start drawing. If we go ahead and remove this line of code, what's going to happen is going to default to 0.5, and that's why now we can't only see part of our image, because 0.5 is the center of our game object. So when we position at 0, 0, the middle of our game object needs to go up here now. Versus like if I want to change this to like 50, 50, what's going to happen is it's going to come over to 50, 50, which is right here, and now the middle of our game object is rendered here. And so if we go ahead and add back our origin, and now we do 0, what's going to happen is now our card's going to move. So then that way it's positioned here at 50, 50 in the top left-hand corner. All right, so now we finished loading in our game assets. That actually wraps up our section on our project setup. And now we're going to go ahead and focus on our game layout. And so we'll be building out the UI of our game. And so in this section, we'll be building out our 4 different card pile types that make up our game. And so we'll have our draw pile, our discard pile, our foundation piles, and then our tableau piles. And so to get started, we're going to go ahead and focus on our card draw pile first. And so for our card draw pile, this is going to be made up of 2 different game object types. A basic rectangle game object, and then multiple image game objects. And so we previously saw how we can go ahead and create image game objects to render out our images to our game. And so what a basic rectangle game object is, this is one of the built-in game objects to Phaser that allows you to create basic shapes. And this can be used for quickly creating these shapes in our game. And that's how we create these rectangles that we see here. So for our card draw pile, we'll be rendering out a simple rectangle to show where the card draw pile is placed in our game. And when there's no cards left in our card draw pile, this will be visible to the player. Then later on, the player will be able to click on that area and shuffle back in their discard cards so they'll continue playing. When there are cards in our draw pile, like now, we'll actually see our image game objects rendered on top of it, and now it looks like we have a stack of cards in that place. Alright, so to get started with our code changes, let's go ahead and jump over to our game scene. And the first thing we're going to do is we're going to add some const variables to our class. And what these are going to be used for, these are just going to be for positioning our game objects where we want them to appear in our scene. And so what we'll do is we'll come to the top of our class and let's go ahead and we'll make some new variables. So first we're going to do debug. And so what this is going to be used for is this is going to be used for drawing additional game objects to our scene. So then that way we can actually see what we're working with. And primarily this is going to apply to our zone game objects. So out of the box, your zone game objects are not visible to the player. And so what we'll be doing is we'll be adding additional rectangles to go ahead and draw out those shapes so we actually see where they're at in our game. For the time being, we'll set this to false, and we'll come back to address this later once we need to implement it. Next, we're going to go ahead and do scale. And so this is going to be used for scaling our image game objects. So currently, when we look at our card, currently it's quite small in our game. So we're just going to go ahead and scale it up by this factor here, 1.5. Next, we're going to go ahead and store our X and Y positions, as well as the frames that are going to reference our card's sprite sheet. So we know which frames are tied to which part of the cards. So the first one will be const, and we'll do card back frame. This is going to be equal to 52. And then what we'll do is we'll do const. We're going to do suit frames. This will be an object. So on our object, we'll do each of our suits. And so we'll have heart, and this will be frame 26, diamond, and this will be frame 13. Then we'll have spades, and we'll do 39, and then finally club, and this will be 0. So real quick, if we take a look at our sprite sheet for our cards, we'll see that all of our cards are grouped by their suit. And so we have our clubs, then we'll have our diamonds, followed by hearts, and then spades. And so this frame here is going to reference the first frame where that suit starts in our sprite sheet. All right, so next we're going to go ahead and do our X and Y positions. So we'll do const, we're going to do our foundation pile, our X positions. And so for our foundation piles, we're going to have our 4 different piles, and so we'll have an X for each of those. So we'll just go ahead and store these in an array. So we'll have 360, 425, 490, then 555. Now, all of these will be in one Y position. So we'll copy this, and this will just be a number. And so we'll change this to foundation pile Y, and we'll just say position. We'll set that equal to 5. Now let's go ahead and do our discard and our draw piles. And so what I'm going to do is I'm just going to copy this here and paste it a few times. And so instead of foundation, we're going to go ahead and do discard pile. And paste that, and we'll change this to X. So for our discard pile, we'll go ahead and do 85 for X, 5 for a Y. I'm going to copy both of these. We'll go ahead and paste it. Let's go ahead and do our draw pile. And so we'll have draw pile X, draw pile Y. So for our X, this is going to go ahead and be 5. Y will be 5 as well, so it's lined up. And now we just need to do our tableau piles. And so for these, we're just going to go ahead and just do our first pile here. And we'll have the other one be based off of this position here. And we'll just have some spacing that's consistent between each of our piles. So we'll copy this. Let's go ahead and paste it one more time. And so we'll have our tableau. We'll have our pile X. And we'll have our tableau pile Y. And so for this one, it's going to go ahead and be 40 for our X. And it'll be 92 for our Y. All right, so next we'll go ahead and create our actual draw pile. And so to go ahead and do that, we're going to put all of that logic inside a new method. So in our class, let's go ahead and add a private method. And so we're going to go ahead and do private, and we'll do create draw pile. And this will return nothing, so it'll be void. And what we'll do in our create method, let's go ahead and call our new method. And we'll go ahead and just do this right above this. We'll do create draw pile. So now in our new method, what we'll do is first we'll go ahead and draw our outline for our pile. So we'll go ahead and draw out our rectangle. And so to do this, we'll put this in another method as well, because we'll be creating a number of these rectangles. And so we just want to be able to reuse that same logic. So what we'll do is we'll do this. Let's go ahead and do draw card location box. And so what we'll want to pass into this method is we're going to want the X and Y of where we're going to draw that rectangle to. And so since this is our draw pile, we'll go ahead and pass in our draw pile X and Y variables that we defined. Now let's go ahead and define that private method. And so we'll do draw card location box. And so we're going to expect X, which will be a number. We'll expect Y to be a number as well. And for this, we won't return anything. We'll just go ahead and create our game object. So let's go ahead and in our method, we'll go ahead and create our rectangle shape. So to do this, we're going to reference our object factory. So we'll do this.add. Let's do rectangle. Now we want to go ahead and do our X and Y position. So we'll pass in the ones that we provided. Now we provide our width and our height. It's not for our rectangle. We want this to be a little bit bigger than our cards. And so we'll have 56 for our width, and then we'll have 78 for our height. And then next we have two optional arguments. It's going to be our fill color and our fill alpha. And so we don't want this to actually be filled in with any colors. So we're going to omit those arguments for the time being. And just so we can line them up where we expect, let's go and put our origin in the top left-hand corner. And now we're going to call set stroke style. And so what this method does is it allows us to basically define that stroke, so that line that defines our rectangle, kind of like a border. And so this will be that outer line that we define. And so when we do this, we can specify the line width, so how thick we want it to be, the color, and the alpha on it. And so for our width, we're just going to go ahead and do 2. And then for our color, we're going to go ahead and do black. So 0x000000. And then we're going to go ahead and apply some alpha, so it's not just plain black. We'll do 0.5. So if we jump back over to our scene, what we should see is now we should see our rectangle for our draw pile being shown here. So now for the rest of our draw pile, we want to go ahead and create our image game objects to sit on top of our pile here. And so for that, we're going to create 3 image game objects that represent our cards, and we're going to go ahead and place them here. So to keep track of those cards, we're going to add a new property to our class because later on, as we were playing our game, we saw that the number of cards in our discard pile could shrink once we're down to 2, 1, or 0 cards. And so we'll need to be able to reference those game objects so we can hide them later. And so by putting those in a property, we'll be able to do that very easily. And so let's add a new private property. We're going to call this draw pile cards. And we're going to go ahead and just set that to a phaser, game objects, an image, array for our type. So then what we'll do is back down in our create draw pile method. Let's go ahead and add in, we'll initialize our array to an empty array. So we'll do our draw pile cards, will be empty array. And now we want to go ahead and create these. So let's do a simple for loop. We'll do let I equal 0. I is less than 3. We'll increment it. Now let's go ahead and create our image game objects. And so for this, we're going to go ahead and create a new method to actually create our cards, because we'll need to create a number of these game objects in our scene. And so let's go ahead and put that inside a method so we can easily do that. So what we'll do is we'll do this. We'll reference our draw pile cards. We'll do push so we can add in a new game object. And then what we'll do is we'll call this new method. So we'll do this, we'll do private, we'll do create card. So for this method, we're going to want our X and Y for we want our card to be positioned. So let's go ahead and reference our draw pile X and then our draw pile Y. So now for our cards, we don't want them to be all in the same position horizontally. Instead, we want them to be stacked. And so for us to have that effect, we just need to bump up our X value as we create our next card in our iteration. And so to do that, we can just go ahead and add a little bit to our X, and we're just going to do I times 5. So that'll give us the effect where on our first iteration, it'll be +0, and this will be +5, and then +10, and that way it's just nudged over just a little bit. So now what we need to do is create this new method. So let's go ahead and do create card, and we'll want an X will be a number, Y will be a number, and now we want to go ahead and actually return something. And so we'll return our phaser, our game objects, and we want to return our image. So now what I'm going to do is I'm going to go ahead and copy this line of code here. We create our image game object from our create method. Let's get rid of that from there. We'll go ahead and place it inside here. Then we're going to go ahead and return that image game object that we just created. All right, so now what we need to do is now we need to modify our properties. And so we'll use our passed in X and Y. We'll do our asset cards. And for the time being now, let's just go ahead and reference our card back frame so we see the back of our cards. And then the last thing we want to do is we want to scale up our game object. And to do that, we can use the set scale method. And so this method, kind of like our origin, we can pass an X and a Y as separate values, or if we pass 1, it'll be applied to both. And this will allow us to scale up our game object either vertically or horizontally by whatever we provide. And so by passing in our scale variable that we created before, we're going to go ahead and make this 1.5 times bigger than what it was originally. And so now we see our cards are a little bit bigger, and we see our 3 card image game objects. All right, so that wraps up our draw card pile for the time being. Like I said, first we're just going to focus on getting our UI, and so we'll have our game objects representing our game present, and then we'll add in our functionality for able to actually move and interact with them later on. So next up will be our discard pile. And so for our discard pile, this will be very similar to our logic that we did for our draw card pile, where we're going to want to have our rectangle for when our discard pile is empty. And then we're going to have two image card game objects on top of our pile for once we have cards in our discard pile. And basically how these are going to work is once we only have one card in our discard pile, our bottom card will not be visible. So like this example here, we have the 7. When we move it around, this is the top game object. But once I draw another card, now we're going to go ahead and update our frame on that top game object, and we can now see that second card below our discard pile here. And so to go ahead and actually add this logic, let's add a new method to our game scene to go ahead and create our discard pile. So what we'll do is right below here, let's do this. We'll do create discard pile. Let's go ahead and create that method. And so we'll come down here. Let's go ahead and do create discard pile. We'll return nothing, so we'll do void for our return type. And now what we want to do is we'll go ahead and create our card location box. So I'm going to go ahead and copy this line of code here. Let's go ahead and paste it. Now we want to change this to our discard pile X and then our discard pile Y position. So we save, we should see our rectangle shape show up in our game. And now we want to go ahead and create our discard pile cards. And so we're going to want to go ahead and store a reference to those because we'll need to modify them as our game is going on. So I'm just going to go ahead and copy this here. Let's go ahead and paste it. Let's update our property name. We'll do discard pile cards. Go ahead and copy that. So let's come up to the top of our class. We'll add in that new property. And our type will also be an array of image game objects. So now what we need to do is we need to create our two image card game objects, but we don't want them to be visible until we actually have cards in our discard pile. So what I'm going to go ahead and do is let's just copy this inner part of our code here where we do create card. So let's copy that. Let's go ahead and do const. We're going to store a reference to this. We're just going to call it bottom card. It'll be equal to this create card. And now we want to go ahead and pass in our discard pile X position and our discard pile Y position. And let's go ahead and get rid of this here because we want these to be stacked on top of each other. So go ahead and save. We should see our new card show up here. And then what we'll do is let's go ahead and add that to our discard piles array. So we'll do push and we will do our bottom card. So now to make this card not visible, we can go ahead and use one of our built-in methods. So we'll do set visible, we'll set it equal to false. And so now that card won't actually be shown to the player. We want to go ahead and do the same thing for our top card. And so we'll just go ahead and update our variable, do top card. Let's add that to our array. And now what we'll do is we'll keep our same X and Y position. And we'll also have this not be visible to the player when the game first starts. All right, so next up, we're going to go ahead and tackle our foundation card piles for our game. And so for our foundation card piles, we'll go ahead and create our outline of where we want those piles to be placed in our game. And so we'll create our 4 rectangles here. But one of the things that'll be different is we're only going to have one image object in each of these piles. And so what we're going to do is as we add cards to our pile, we're going to go ahead and use that one game object. And we're going to go ahead and make it visible to the player. And then at the same time, we're going to go ahead and update its texture to go ahead and show whatever card we just added to the pile. So as an example, now that we have our ace here, when I bring our 2 on top of our ace, what's going to happen is we're going to go ahead and just keep that same image game object that was already there. We're going to destroy the card that we just added, and then we're going to go ahead and update the texture of that original game object. And so for each of these piles, we only need to have one image game object for each pile. And so to go ahead and add that logic, let's jump over to our game scene. And we're going to want to go ahead and keep track of these piles. So let's make a new property to do that. I'm going to copy this here. I'm going to paste it. And so let's go ahead and do our foundation pile cards. And this will be an array of our card image game objects. And now let's go ahead and make a new method to create these piles. So let's do this. We'll do our create foundation piles. Let's go ahead and create that method. Let's come down to the bottom of our class. We're going to do create foundation piles. We won't return anything. Now let's go ahead and initialize our array. We'll do this. We'll do our foundation pile cards will be equal to an empty array. And so now what we want to do is we originally defined our X positions for where our foundation piles to be placed in an array. So we're just going to go ahead and loop through this array to grab our X values, and then we'll go ahead and create our rectangle boxes as well as our card game objects using these positions. So down in our method, let's go ahead and loop through that array. And so we'll do our foundation pile X positions. We'll go ahead and do for each. So for each X value in our array, let's go ahead and create our draw location box. I'm just going to copy this here, go ahead and paste it. And so what we'll do is we'll have X, and now we want to go ahead and reference our foundation pile Y variable. And so let's go ahead and update this, and that should create it in the correct location. And now we want to go ahead and create our cards. And so what we'll do is we'll do const, we'll store them in a variable do card, will be equal to this, we'll do create card. Now we're going to go ahead and pass in X, we're going to go ahead and pass in our foundation pile Y position, and we won't go ahead and make it not visible for the time being. We'll go ahead and leave it visible so we just make sure our logic's working. And so we'll do this, we'll do our foundation pile cards. Let's go ahead and push in our card to our array. So now when our scene refreshes, we should see our 4 card image game objects show up in our scene. And since we made sure they're in the right positions, let's go ahead and set visible. We'll go ahead and set equal to false. So now we should see just our rectangle boxes shown in our scene. All right, so the last pile we need to create now is going to be our Tableau piles. And so for our Tableau card piles, these are going to be a little bit different than our other card piles, because what we need to do is we're going to place multiple image game objects on top of each other like this. And so what we're going to do is we're going to create a container game object to place all of our game objects inside for each of our piles. And so what a container game object is, it's just a way for you to group similar game objects together, and then that way you can do things to the parent container and it'll be applied to all of the child game objects. A good example of this is this stack of cards here. By positioning our container at the position that we want to be in, so like right here, for these 3 cards that are visible here, we don't need to actually specify our X property on these. Instead, we can have them be positioned based on that container game object here. And so by doing this, we'll be able to only have to worry about modifying our Y value for our stack of cards, and we'll let our container's positioning handle all the X position for all the cards inside this container. And so there's much more you can do with containers, but primarily for our game right now, that's how we'll be using them. We'll be using them for positioning our game objects together, so we don't have to do them individually. So to get started with this logic, let's go ahead and jump over to our game scene. And similar like what we did before, let's go ahead and make a new method to go ahead and store our logic for this functionality. And so we'll do create Tableau piles. We'll go ahead, we're going to return void from this. Let's go ahead and call our method from up in our create method. So we'll go ahead and jump up there. And so now what we're going to want to do is for our 7 piles, we're going to have a container for each one. And so we'll want to go ahead and store a reference to each of those containers so we can reference them. And so what we'll do is let's go ahead and copy this here. Let's go ahead and paste it. For our property name, we're going to go ahead and do Tableau containers. And so now for our type, it's not going to be an image game object. It's going to be a container game object. So now what we'll do is down in our method, let's go ahead and initialize our array to an empty array. So we'll do our Tableau containers will be equal to an empty array. And now what we want to do is for each of our card piles, we need to go ahead and create our container and then create our image game objects to place inside them. So to do this, let's go ahead and do a for loop. So we'll do for, we'll do let I equal 0. If I is less than 7, we'll go ahead and do our loop, and we'll go ahead and increment this by 1. All right, so the first thing we're going to do is we want to go ahead and create the container game object for each of our piles. And so to do this, we'll make a new variable. We'll do Tableau container will be equal to this. We'll use our factory to go ahead and create our game objects. And on here, we have a method for creating our container game object. So like our other game objects, we need to specify our X and Y value for where we want our game objects to be placed in our scene. And so for the time being, we're going to make a new variable X. So we'll just do X. Now let's go ahead and reference our Tableau pile, our Y position. And so for our containers, because we just placed game objects inside them, we have the option to pass those game objects when we create our instance. For now, we're just going to pass in an empty array because we don't have any game objects to add yet. So figuring out our X value, what we need to do is we have our initial starting X position, but as we iterate through our array, we want to go ahead and bump this up, very similar to like what we did up here when we created our draw card piles where we update our X value. And so to do that, we'll make a new variable. We'll do const X will be equal to, and we'll do our Tableau pile X position. And so we'll go ahead and add, we'll do I times, we'll do 85 pixels, just so we'll have that spacing between each of our piles like we saw here. So then let's go ahead and add in our container to our array. So we'll do this, we'll do our Tableau containers, we'll do push, and let's go ahead and add in our Tableau container. So now that we have our container game object, It's not going to be visible to the player, so now we actually need to add game objects inside it for them to show up in our game. And so what we'll do for the time being, let's go ahead and just create one card game object, and just so we can see them appear where we expect them to appear. And so we'll do const, we'll do our card game object will be equal to this. We want to do create card. And so for positioning our cards, we want to go ahead and set these at 0, 0. And so when we place a game object inside the container, it's going to be placed relative to that container's position. And so this will make more sense once we actually place our cards. So let's go ahead and add this game object to our container. And to do that, we need to reference our container game object, and we're going to use the add method. And this will allow us to place that object or an array of objects inside our container. And so we'll go ahead and pass in our card game object. All right, so once our scene refreshes, we're going to see now we have our 7 card piles, and we have our cards positioned where we want them to be. And so what's happening is we're creating that container game object that's not visible, and we're positioning it right where we want this to be. When we add in this card game object, it's going to use that relative position. Since we passed in 0, 0, it's going to place that card in the exact same position. Versus if we did something like this, where we go ahead and change it to be like 20, we'll see now our container would be placed here, and relative to that, our card would come down 20 pixels, and so it's 20 pixels away from that original position. And so that's something to keep in mind when you're positioning your game objects is when they're in the container, that position of the container will affect where your game object will appear. All right, so now we have our initial card. What we need to do for our piles is we need to start adding more cards to each of our piles as we increment them. So for our second pile, we should have 2 cards, 3 in the third, 4 in the fourth, and so on. And so to do this, we'll go ahead and do a nested loop inside this loop here to create that functionality. So what we'll do is let's do 4. We're going to do let j equal to 0. When j is less than I plus 1, what we'll do is we'll do j plus equals 1. And we'll go ahead and create our card inside that loop. And now we need to go ahead and update our y position to use that new variable. So do j times 20. Let's go ahead and save. So now when our scene refreshes, we'll now see our 7 card piles, and we'll see we have more cards increment as we go along here. So what we did here is we just have this nested array, and basically what we do is we have more iterations through here. That's going to bump up our I value, which means we're going to run this iteration more and more as we get further along in our iteration from here. So as an example, we're on our first pile. Because I is 0, we're setting it to really 0 plus 1, so we're going to run this one time. When I is 1, we're going to do add 1, so it's going to be 2. So we're going to have 2 iterations, then 3, and so on, so we get our cards. And so by using that j value for our y and basing it on that, that's how we can move our cards down to get the stack effect here. With our game layout completed, it is now time to start focusing on adding support for our player input. And so for the input in our game, we're going to have 2 main types. The first will be click events. So when the player is on the title screen, we'll support click events here. But then for our game scene, we'll be able to click to draw cards from our card draw pile. Our second one is going to be for being able to drag cards in our game. So we'll be able to click and hold and drag our cards around our scene, and we'll be able to move them to our different piles. So to get started with our input, we're going to focus on being able to drag our cards first. So let's go ahead and jump over to our game scene. So in order to allow our player to click and drag our game objects in Phaser, the first thing we need to do is we actually need to make them interactive. And by making them interactive, this is going to allow us to listen for our various built-in input events, and then we can go ahead and react to this in our code. And so to do this, we need to use the setInteractive method on our game object. So let's go ahead and come to our createCard method. And what we're going to do is after we do our setScale, we're going to go ahead and call another method, and we're going to do setInteractive. And so what this method does is going to go ahead and enable our input for our game object, which is going to allow us to listen for our pointer events. We can listen for when a game object is dragged around our scene and different things like that. And so with this is how we can create really cool things like hover effects. We can move our game object with our mouse. We can go ahead and have it be a button that can be clicked and we can listen to, and different things like that. And so when we call this method, by default, we don't have to pass any arguments to this. And this is going to give us our basic input events like the pointer over, pointer out, click events, different things like that. But in order to make our game objects draggable, we need to go ahead and pass an additional argument to this, and this is going to be an object. And what we want to do is we want to go ahead and set draggable to be true. And so when we do this, this is now going to allow us to listen for that drag event on our game object. And so in our game, we're not going to want all of our cards to be draggable. So what we're going to do is we're going to update our method to have this be a argument that we can pass. And so let's go ahead and add draggable, and we're going to have this be a Boolean. And then what we'll do is we'll go ahead and set that to our argument that we provide. So now in our code, when we call our create method, we need to go ahead and update that value. So what we'll do is we'll start with our discard pile. So for our discard pile of cards, we want to go ahead and make those draggable. So what we'll do is let's go ahead and pass in true. Next, for our foundation piles, those we don't want to actually be able to drag. So we're going to go ahead and pass in false. Our tableau pile of cards, we want to be able to drag them around. So we'll go ahead and pass true. And then for the last thing we need to do is we need to go ahead and update our draw pile, and we don't want those to be draggable, so let's go ahead and do false. So after we save our code changes, there's going to be no visible differences in our game, and the reason for that is this just enables our objects for input. For us to be able to actually do anything with it, we need to register an event listener for our various input types, and then that's going to allow us to handle those events in our game. So what we'll do is let's come to our create method. We're going to go ahead and make a new method, and we'll go ahead and call that from here. So we'll do this. We're going to go ahead and do create drag events. So what we'll do is let's copy that. Let's go ahead and come to the bottom of our class. We'll go ahead and add in our new private method. We'll have create drag events. This won't return anything, so let's add in void for our return type. And now what we want to do is we want to go ahead and create our event listeners for our drag events. And so for our drag events, there's going to be a drag start event for once we start dragging our game object around. There's going to be the actual drag event. So as our mouse moves around our scene, we'll be getting event details for every time that pointer moves. Then finally drag end. So once we release our card and we stop moving it, we'll get that drag end event. So we'll know where our card ended up in our scene. And so to go ahead and add all that logic, what we're going to do is we're going to create a method for each of these event types, and then we'll have our logic inside its own method. So what we're going to do here is let's go ahead and create these 3 new methods. So we'll do this. We'll do create drag start event listener. And what I'm going to do is I'm going to copy that. Create our method. We'll have void for our return type. Then what I'm going to do is I'm going to copy this. We'll paste it 2 more times. And so we'll have drag start. Then we'll have our drag event listener. And then we'll have drag end. I'm going to go ahead and copy this. Let's go ahead and paste that twice. And we'll add in our 2 other methods. And let's go ahead and update our method names. All right, so we're going to go ahead and start on our create drag start event listener. And so what we need to do is if we want to go ahead and list for events in our game, we need to rely on what is called the event emitter class and phaser, which is used internally to emit a variety of events. And this same class also allows us to register an event listener that will be called when this event is actually being sent out. And what's really cool about phaser is it uses this class internally on most resources, which means we can listen for all kinds of events on our game objects, our scenes, our plugins, and much more. And so by default, any object that has a built-in event emitter will be able to use the on method to register our event listeners. And so since there's a variety of ways we can listen for events, we need to decide what we want to listen to our event on. And so we could listen on our game object level, but if we did that, we would need to go ahead and create an event listener for each of our different game objects, which is not ideal. It wastes a lot of resources. What we can do instead is we can listen for our input events on our input plugin, which will fire every time there's any type of event for any of our game objects. And so by doing this, we'll have one event listener that we can go ahead and get details about which game object was moved and react accordingly. So to go ahead and do that, we need to reference our input plugin, and then we're going to go ahead and use that on method. And so with the on method, what we need to do is we need to provide which event type we want to listen for. And then we want to go ahead and provide our callback function that'll be invoked when this event is actually fired. So for our event type, we're going to go ahead and do phaser. We want to do input. We want to go ahead and register events. And then we want to go ahead and do our drag start event. And so this is just a variable for the drag start string that we're providing for the event we want to listen for. Now we want to go ahead and provide our callback. And so in our callback, we'll go ahead and add in our function. And then so in our callback function, we're also going to add a few arguments. And so anytime phaser emits an event, it will typically send the relevant details that are tied to that event. As an example, for our drag events, we're going to receive details on our mouse, so our pointer, where it's at in our game, and we're also going to receive details on which game object was involved in that event. So when we start dragging an object, we'll get that object's details. So we need to go ahead and add those in, so we'll go ahead and add in pointer. So this is going to be phaser. That'll be our input, and it's going to be a pointer object. Then we'll have our game object. And so for our game, right now we only have our image game objects that we're enabling for input. So we're going to go ahead and type for that. So it's going to be a phaser, game objects, and it's going to be an image. So all we're going to do for the time being is we're just going to go ahead and do console log. And what we'll do is we'll do our gameObject.x, our gameObject.y, and just so we can see something happening. And then what we'll do is we'll go ahead and update the alpha on our game object so we know which game object is actually being moved. And so we'll do set alpha, and we'll go ahead and do 0.8. So if we go ahead and save, if we go ahead and click one of our cards and we hold it down, what we should see right away is we should start seeing messages appear in our console with the details of our X and Y of that game object. And we should see now our game objects, our alpha, is being updated because we're now starting that drag. And so how that works is as soon as you click on your game object, that is the trigger for our drag start event. And then as you hold your mouse down and move it around, that would be our next event. And so now what we want to do is we want to apply the same logic to our other methods. So what I'm going to do is I'm going to copy this here, go ahead and paste it in our other two methods. Then what we want to do is we want to update the event we're listening for. So for create drag event listener, we just want to listen for our drag event. Then on our drag end event listener, we want to change this to drag end. Then what we'll go ahead and do is, and when we get our drag end event, we're going to go ahead and reset our alpha back to 1. So that way our card will be visible again. And then what we're going to do in our drag event listener, let's go ahead and get rid of our set alpha call, and we'll go ahead and save. So now what we should be able to do is if we click on one of our game objects and we move our mouse around, we'll see that we're getting our X and Y position multiple times now. So anytime our pointer moves, our event triggers, and as soon as we release our mouse, it fires one more time. We see our alpha is now updated. So now what we need to do is now we need to actually update our game object to move as our mouse moves around our scene. And so to do that, we're going to go ahead and add a few more arguments to our callback here for our drag event listener. And so we're going to go ahead and add in drag X, which is going to be a number. And then we'll add in drag Y, which will also be a number. And so the drag X and drag Y arguments are going to be the X and Y position of where our mouse is actually moving to in our scene. And then that way we can go ahead and update our game object to be in that position. So what we're going to do is we're going to do game object. We're going to use set position to update our X and Y values. And then we're going to use our drag X and our drag Y numbers to go ahead and update our position. So now if we go ahead and save, we should be able to click on one of our cards and move it around our scene. Alright, so next, while we're dragging our game objects around in our scene, one of the things we might have noticed is that our game objects are appearing on top of each other or behind each other. And what this is actually the depth of our game objects that are being added to our scene. And so by default, when you add your game objects to your scene, all of them have a depth property and it's set to 0. And so they're all on the same depth layer when it's being rendered out to our scene. And so by default, when we add our game objects to our phaser scene, phasers are going to go ahead and render those out in the order that we add them to our scene. There's a few caveats to this, like if we're using containers and things like that, but for the most part, this holds true. And so a good example of this is going to be our draw card pile here. And so when we add in our game objects, we get this stack effect here because as we add in those game objects, they're being rendered on top of each other in those positions. And so as an example, if we come up to our create draw pile method, what I'm going to go ahead and do is I'm going to go ahead and update the depth of our middle card game object. And so then that way it's going to display on top of our other cards. And so as an example, we do this, let's reference our draw pile cards, and we're going to reference the middle one. So we'll use one for our index, and then we're going to use the set depth method. And so this is going to allow us to modify that property on our game object. And so if we go ahead and set this to 2, what's going to happen now is because that depth is higher than our other game objects, it's going to be drawn on top of it. And so this is one of the ways we can control how our game objects appear in our scene and have those game objects be drawn on top of other ones. And so a good way to think of depth is this is kind of like the z-index for the CSS property on your HTML elements. And so the higher your depth is, the higher it is in the display order, it'll be displayed on top of your other objects. And the lower it is, it'll be displayed under the other objects. And so typically this is really useful for like when I do like UI elements, we'll always want those to be placed on top of everything else in our scene. But for our case, because we want our cards to actually be on top of each other when we're moving them around, we'll also need to make use of depth. And so what I'm going to do is I'm going to go ahead and remove this code. And so what we'll want to do is as we move our game objects around our scene, we'll want to go ahead and update our depth property to have that game object be on top of all of our other game objects. Because ideally, as we drag this around, we'd want it to be in front of our card stack here. And so to do that, we'll update our event listeners to modify our depth property on our game objects. So what we'll do is after we do our set alpha here, we're going to go ahead and do game object. We're going to go ahead and do set depth. And we're going to go ahead and set this equal to 2. And let's go ahead and copy this. And then on our drag end event, we'll go ahead and reset it. And so I'm going to reset this back to 0. All right, so we go ahead and save and we test our changes. It looks like we still have the same issue. So what's happening here is our game objects are inside a container, and that container depth overrides the depth of our game object on our scene level. And so even though we're updating our depth on our card game objects, what we actually need to do is we need to update the depth on our container, so then that way it's higher in our display order than our other containers. Real quick, we're going to go ahead and test our depth and make sure it's working. What I'm going to do is I'm going to come up to our create draw pile method, and what we're going to go ahead and do is we're going to go ahead and pass in true for making them draggable, just so we can see if our code's working. So what I'm going to do is now if we click and drag our draw pile, if we move that card around, we can see it is now displaying on top of all of our other cards, even though our draw pile was created before all of our other image game objects in our scene. So what I'm going to do is I'm going to revert that back to false. So in order to address the issue of our depth, we'll need to go ahead and update our code to update the depth on our containers instead of our card game objects for our Tableau. And so to do this, we'll need to store some data on our game objects so we know which card pile our card actually belongs to. So in order to store custom data on our Phaser game objects, one of the ways we can do this is we can use the built-in data manager on our game objects. And so our data manager is a custom class that allows us to store and retrieve data on our game objects instance. And this works as a simple key value storage system where we can provide a key, which will be a string. And this is going to be the unique name of what we want to store. And then we can provide a value of any type. So like a number, an object, a Boolean, anything like that. And Phaser will go ahead and store this data on our game object in the data manager instance. And so for as an example, if I wanted to give each of our cards a unique ID, we could store this in a field called ID with the actual value of the ID that we provide. And so like maybe this could be the unique identifier for the card. So maybe like the card suit with the card value. And so a good way to think about our data manager is to think of this as just a basic object in JavaScript where your key is one of the keys on your object and your value is the value associated with that key. And so by using the built-in data manager, we can store any type of data we want, and we don't have to worry about creating a custom class to hold this information or worry about overwriting the properties on our game objects that Phaser uses internally. And so to go ahead and use our data manager on our game object, we need to go ahead and make use of the set data and the get data methods. And when we use these methods, Phaser will internally create an instance of the data manager class on our game object if one does not exist, and then go ahead and store the data that we're trying to store on our game object. And so go ahead and do this. Let's go ahead and go to our create card method. And so what we're going to want to go ahead and do is on our create card, we're going to go ahead and call a new method. We're going to go do set data. And so when we call the set data method, there's a few different ways we can pass what we want to go ahead and store on our data manager. So the one way we can go ahead and call this is we can provide our key and then the value we want to go ahead and store, and that will store that single property on our data manager instance. Or we can go ahead and provide an object with our key value pairs, and Phaser will store all of that data for us on our game object. And so for storing our data, what we're going to want to do is we're going to need to store a few different things. The first one's going to want to be our card's position, so our X and Y value. And the reason for that is as we're moving our game objects around in our scene, we're going to want to add validation logic. And if we move a card to a position that it's not supposed to go in, we'll want to go ahead and snap our card back to its original position if it's not a valid move, instead of allowing the player to place it anywhere in our scene. And so we'll be making use of that X and Y value, so then that way we know where to put our card back to. The other properties we want to store is we want to go ahead and keep track of our card and our pile indexes for our Tableau piles. And so for our Tableau piles, basically we want to know our index, so then that way we know which container our card game object is associated with. And our second one will be our card index. We're going to want to know which card in our stack we're actually moving around in our scene, so then that way we can go ahead and move the whole stack of cards around or check to see if that card is actually eligible to be moved. And so we'll be go ahead and storing those four properties. And so to do that, we'll go ahead and store our X. Let's go ahead and store our Y. And so we're just doing our shorthand here to create a field called X, and then the value will be our X here. Same thing for our Y. We're going to do the same thing for our card index, and then we'll go ahead and do our pile index. And so now for our card and our pile indexes, these are going to come into our method when we provide them. And so we're going to make these optional. And so what we'll do is we'll do our card index and as our argument. This will be a number, and then we'll have our pile index, which will also be optional, and this will be a number. All right, so now that we update our create card method, what we want to do is we need to go ahead and update our Tableau pile card creation to go ahead and pass in our card and our pile indexes. So what we'll do is let's come down to where we create our Tableau pile cards. And so now what we'll want to do is we want to go ahead and pass in J and then pass in I. And so J is going to reference the index of our card in our stack, and then I is going to be which index, which Tableau pile index the card's associated with. All right, so now we're storing data tied to our cards. What we need to do is we need to update our event listener for our drag start event to go ahead and use this information. So what we'll do is we'll come to our create drag start event listener. And what I'm gonna go ahead and do is I'm gonna do console log. We're gonna reference our game object, and then we're gonna reference data. And so what the data property does is it allows us to reference our data manager. And then what I'm going to do is I'm just going to use the list method to go ahead and get all the properties that are stored in our data manager that we've added. So now if we click on one of the cards in our scene, we'll see right away we get an object with all of the properties and the values that we added. And so for the card that we just dragged, we can see this is tied to index 2 for our pile and our card index 2, versus if I click and move this card here, we'll see now it's tied to our second index for our pile, and our card index is 0. And so now we can see that we're able to store our data and it's being stored properly. We now need to use that to go ahead and update the depth of the relevant container in our scene. And so what we're going to go ahead and do is right in our console log here, let's go ahead and get rid of this. What we want to do is we want to try to grab our pile index from our data manager. And if it exists, then we know it's a Tableau pile card. If it does not exist, then we know it's going to be a discard pile card, and we don't need to update a container's depth. Instead, we can just update the depth of our game object. So go ahead and do that. Let's make a new variable. We'll go ahead and do const. We're going to do Tableau pile index will be set equal to our game object. We'll use the get data method. And so what this method does, it allows us to retrieve a specific property or an array of properties from our game object, and then Phase will return those for us. And so for us, we just want our pile index from our data manager. And so if it's found, Phaser is going to return that value. Otherwise, it'll return undefined if it does not exist. And so for our type, we're just going to go ahead and type this as a number or as undefined. So now what we'll do is we're going to check to see if that's not undefined. So if our Tableau pile index is not undefined, then what we want to do is we want to update our Tableau container that our card's associated with. And so to do that, we'll reference our Tableau containers. We'll use that Tableau pile index to grab the correct one from our array. And now we'll do set depth. We'll go ahead and set that to 2. Otherwise, if it is undefined, then we just want to go ahead and set the depth on our game objects. We're going to paste that here. And so what I'm going to do is I'm going to get rid of this. And let's go ahead and get rid of our console log for our details. And we'll go ahead and save. So now the last thing we need to do is now we need to do the same logic inside our drag end event listener. So we can update either our container or our card game object's depth. So what I'm going to go ahead and do is I'm just going to copy this code here. We'll come down here. Let's go ahead and get rid of our console log. We'll go ahead and paste it. And so now what we want to do is for our depth, instead of setting it equal to 2, we just want to go ahead and set it equal to 0. Same thing for our image game object. We'll go ahead and set that to 0. Alright, so go ahead and save. And if we grab one of our card image game objects, if we try dragging around our scene, we'll see now it displays on top of our other containers. And if we try dragging one of our cards that are behind our other cards, we'll see that the cards on top of it still appear on top of it. And that's what we want, because we'll want to drag that whole stack and have them appear in that order. Alright, so the next thing we want to do is we want to go ahead and update our cards to go ahead and keep the updated X and Y value stored on our game object of where our game object is currently at. And so then that way we can create that snapback effect that we refer to here, or if we try placing a card where it doesn't belong, we go back to the original position. And so to do that, we'll want to store our game object's X and Y position when we start our drag event. And then on our drag end event, if it's not a valid position, we want to go ahead and update it to go back to that original position. So what we'll want to do to store that value on our drag start event listener, let's go ahead and reference our game object. Let's do set data. We'll go ahead and pass in an object. And so for our X value, this will be our game object's X position. Our Y will be our game object's Y position. And now what we want to do is in our drag end event listener, we want to go ahead and update our position to go ahead and use those stored values. So after we go ahead and do our alpha check, what we'll do is we'll do our game object. Let's use the set position method. And now we need to go ahead and grab our X and Y values from our data manager. And so we'll do our game object, get data, and we'll go ahead and pass in X, and this will be a number. And then we'll also do our game object, .get data, and we'll grab our Y property from our stored data. and this will also be a number. So now if we go ahead and save, if we try moving our cards around in our scene, what should happen now is after we release our mouse, our card should now snap back to its original position. So now that we have our basic movement function being handled, the next thing we do is we need to add support for moving a stack of cards. So in the game of Solitaire, when we pick up our face up card in our tableau pile, we need to move all of the cards that are on top of that card as well. And so in order to do this, we'll need to make use of that pile index and the card index properties that we're storing in our data manager for our cards. So that way we can grab the relevant cards on top of that card and move them around our scene. And so to go ahead and do this, what we'll do is we're going to make a new method to figure out which cards actually need to be moved. So what we'll do is let's come down to the bottom of our class. Let's add a new private method, and we're going to do get number of cards to move as part of a stack. And so for this method, what we'll do is we'll go ahead and we're going to receive our tableau pile index and our card index, and that way we can go ahead and reference our correct containers. And so we'll have our tableau pile index. This is going to be a number. We'll have our card index, which will also be a number. And then what we'll do is we're going to return a number of cards we need to actually move. And so for the time being, I'm just going ahead and do return 0. All right, so now what we'll need to do is based on our tableau pile index, we want to grab the relevant container. And so from that container, we need to figure out how many image game objects are inside that container. And once we have that, we can compare that to our cards index that we have stored. And so the reason that this will work is when we add game objects to our containers, they are stored in the order that we add them to it. And so due to that, we can rely on that index that we set in our data manager to know what other cards are currently stacked on top of that card. And so to go ahead and do this, the first thing we're going to do is we're going to make sure that our tableau pile index does not equal undefined. If it is undefined, then we want to go ahead and return 0. If it's not undefined, now what we want to do is we want to grab our relevant tableau pile and figure out how many cards are inside that container. And so to do that, we'll go ahead and use our length method. And so what we'll do is we're going to do const. Let's make a new variable. We'll do const. Let's do last card index, and our container will be equal to this, our Tableau containers. Let's go ahead and provide our Tableau pile index. And now we're going to go ahead and use our length property, which will give us the number of game objects inside our container. And now because this gives us back our size, we're going to go ahead and subtract 1. And so the reason for that is we have a 0-based index. And so even though if we have one object in our container, to grab a reference to it, we want to go ahead and return a 0 for that 0-based index. All right, so then what we'll need to do now is we need to figure out how many cards to return based on this value here. So as an example, if I grab this card here in this stack of cards, the index on this card should be 1, but then we should have 4 cards, and so the last card index should be 3. And now if we go ahead and subtract it, we'll know that 3 minus 1 is 2. We have 2 cards we need to move as well as this card here. Versus if I grab this card in the stack, we know that this is the index 3, and so our last index will be 3, so it should be 0. We should return 0 cards in addition to the card we're moving. And so to go ahead and do that, we're just going to do return, and we're going to do our last card index minus our card index. And so that's going to give us that number of cards we actually need to move for that stack. All right, so now that we know how to figure out how many cards we need to move as part of our stack, we now need to update our drag event listener to also move those cards. So what we'll do is we'll come to our drag event listener, and inside our event listener, in addition to updating our game object's position, we want to go ahead and update that stack of cards as well. And so what we'll do is below our code here, let's go ahead and do const. Let's grab our Tableau pile and our card index values from our data manager. So what I'm going to do is I'm going to copy this line here to grab our Tableau pile index. Next, for our card index, I'm also going to go ahead and paste it one more time, and we'll go ahead and change this to be card index. And so instead of pile index, this will be card index, and then we'll just go ahead and type this as a number. And so the reason we're doing that is we're going to rely on our pile index. If it's not set, then we're not going to do anything. If it is set, then we know our card index will also be set as well. So now what we'll do is we'll have our check. So we'll do if our Tableau pile index does not equal undefined. Now we want to go ahead and do our logic. And so first we need to grab our number of cards we need to move. And then for each of those cards, we want to go ahead and update their position. So what we'll do is make a new variable, do const number of cards to move. We'll set that equal to this. We'll do get number of cards to move as part of a stack. Let's pass in our Tableau pile index and our card index variables. Now we want to go ahead and loop through each of those cards. So what we'll do is we'll do for, we're going to do let I equal 1. And then we'll do I is less than or equal to our number of cards to move. And then we'll go ahead and increment I by 1. So now what we'll do is if there's 0 cards to move, we won't actually go ahead and do our for loop. If there's at least 1 card to move, we'll go ahead and update it. So now what we want to do is we need to grab that image game object from our container by its index. So then that way we can go ahead and update its position. So currently in our event listener, we only get the game object that our drag event is currently associated with. And so now we need to go ahead and grab it from the container directly. So to go ahead and do that, we'll reference our Tableau containers. And so in our array, let's grab our Tableau pile index to grab that specific container. And now we're going to use the getAt method. And so the getAt method allows us to provide an index of the game object that we want to grab from our container. And then it's going to go ahead and return that to us. And so for getAt, we're going to go ahead and provide a type. And so we know inside our containers, we're just doing image game objects. So we're just going to go ahead and type that. So we have game objects.image. And now what we'll do is we'll do our card index and we're going to go ahead and do plus I. And so what we're doing here is by using the getAt method, we're taking the card index of the card game object that's currently being dragged. Now we're adding I to it. So if we need to move 1 card, it's going to be like index 1 plus I, so it'd be 2. Or even like here, it'd be 1 plus 2 to grab this card here. And so this is going to return that game object to us. And then what we can do is we can go ahead and use the set position method to update our X and Y value. And so what we'll do is we'll update our X to match our drag X and then our drag Y. What we need to do is we need to also use our drag Y, but then increment this by 20 times I. And so that's going to match how we're stacking our cards when we place them inside our containers. Is we want to do the same logic here. So if we go ahead and save, if we grab one of our cards now, we can see we can actually drag our stack of cards around. And now we just need to go ahead and update our drag end event to go ahead and update our positions after we release our mouse. All right, so to go ahead and do that, let's come down to the bottom of our event listener for our drag end event. And what I'm going to go ahead and do is we're just going to copy some of this logic here. So let's go ahead and copy our if statement, and we'll also copy our variable for our card index. Let's go ahead and paste that. And so what we're going to go ahead and do is we'll grab our card index from our data manager. If it's not undefined, we need to figure out which cards to move. And now we need to go ahead and update our position. And so what we'll go ahead and do is we need to just go ahead and grab a reference to the card that we're actually moving. So we're going to store that in a variable. Do const, we'll do card to move will be equal to this. We'll do the getAt to grab our game object. Do is we'll manually set our card to move and we'll call set position. And so the reason we're doing that is we need a reference to this object. So now we can go ahead and reference the data manager on that image game object itself. So what we'll do is we'll reference our card to move. Let's do get data. We'll want to grab our X value from there. And we'll go ahead and do as a number. Let's copy that. And we'll go ahead and do the same thing here. But we'll change this to be Y. So now if we go ahead and save, we should see now when we move our stack of cards, they snap back to their original position. With our logic for dragging cards in place, the next type of input we're going to handle is going to be our click events for our draw pile. And so when we want to go ahead and draw cards from our draw pile, we need to listen a click event listener on our game objects. And so instead of actually adding this event listener for our various card game objects here, we're going to use a new type of game object called a zone. And so a zone game object is a special type of game object that does not actually render out in our phaser scene. Instead, this type of game object is mainly used for creating drop zones or input areas and checking for object overlaps. And so the zone object has a bunch of built-in helper methods for these types of checks. And so the zone game object is basically a rectangle game object that's not visible to our player, and we'll be using this game object type for drawing cards, and later on we'll be using it to check if our moves are valid when we move our cards around between its various card piles. And so what we're going to do is we're going to create this zone game object over our card draw pile, so then we can go ahead and listen for our click events on that game object. So to go ahead and do this, let's go ahead and come to our create draw pile method, and what we'll do is after we create our cards, we want to go ahead and create our zone game object. And so to go ahead and do this, let's make a new variable, store a reference to our game object. So do const, and we're going to do draw zone. We set that equal to this dot add. And so on our factory, we want to use our zone method to create our zone game object. And so now you specify our X and Y position for where we want to position this at, and then we'll provide our width and height for the rectangle of the shape that we're creating. And so we're gonna go ahead and do 0, 0. Now we wanna go ahead and do our card width. We're gonna times that by our scale, and we're gonna go ahead and increment it by 20, just so it's a little bit larger than our card image game objects that we're currently drawing. Next, we wanna go ahead and do our same thing for our card height. So we'll do our card height, and we'll times that by our scale, and we'll go ahead and increment it by 12, so it's a little bit larger as well. Now for positioning, we want to go ahead and set our origin to our top left-hand corner, so we'll set it to 0. And now we want to go ahead and make it interactive, so then we can go ahead and listen for our events. So we'll go ahead and do set interactive. We won't provide any arguments because we don't need to be draggable. And so now we need to go ahead and listen for that event. And so previously we used our input plugin to go ahead and listen for our events in our scene. Now we're going to go ahead and use a game object and see how we can listen for events on specific objects. So to do that, we'll reference our draw zone, and now we're going to use our on method to reference our event emitter for this specific game object. And now we need to provide our event. So it's going to be phaser, input, events. We want to use our pointer down event. And so for our pointer down event, this is going to be when the mouse actually clicks down or our pointer interacts with our game object. And now we need to do our callback. And so in our callback, I'm just going to go ahead and do a console log for the time being, so make sure everything's working. And we'll do console log, and we're going to say draw card. So after we do that, if we go ahead and click on our draw card pile, we'll see now our console log message shows up. And so to make it actually easier to work with zone game objects, one thing I like to do is I like to actually draw out the rectangle shape that represents the zone game object. So then that way it's very easy to see where that zone is in our game. And so what we're going to do is we're going to make use of this debug variable we previously added. We've not used it in our code. And so what we're going to do is if debug is set to true, we're going to go ahead and draw out our rectangle to represent our zone. So in our create draw pile method, what we're going to do is let's go ahead and add a new rectangle. So we're going to do if, and we'll say if debug, so if it's set to true, we're going to go ahead and add a rectangle game object. So let's reference our factory, and we'll add in our rectangle. So now for this, we want to go ahead and use our properties from our draw zone so it actually matches it. And so we'll do our draw zone game object, we'll reference our X, we'll reference our Y, and then we'll reference our width and height. So for our color, we're just going to do red. So let's do 0x, ff, 0000, and now we'll do 0.5 for our fill alpha, so it's a little bit transparent. And now we want to go ahead and update our origin, so it's at the exact same position, and so we'll do 0. So when we save, because debug is not set to true, we don't actually show anything. So let's go ahead and update our code, and now we'll see our red rectangle shows up, and now we can see where that zone is. And so if we try clicking anywhere outside that red rectangle, nothing happens, but the moment we click anywhere inside it, we now see our console log message. All right, so the last thing we're gonna go ahead and do with our draw card pile for the time being is we're gonna go ahead and update our click event listener to go ahead and add cards to our discard pile. And so in the game of Solitaire, as we draw new cards from our draw pile, we're automatically gonna place them on top of our discard pile. And from this pile, the player will be able to play those cards to the foundation or tableau piles. As they play cards from our discard pile, they'll be able to keep playing those cards one after another, as long as they can play the top discard pile that's currently displayed. And so for the time being, all we're going to do is we're just going to update our draw card pile to make our two card game objects we created earlier to actually be visible. So what we'll do is let's come back to our event listener for our click event. And we're going to go ahead and let's get rid of our console log. And so now what we want to do is we want to go ahead and reference our two card image game objects here in our discard pile. And we want to go ahead and make them represent the card that we just drew. And so to do this, we'll want to go ahead and update our frame so we know which card we're displaying. For the time being, this will just be our card image back frame. But later on, like if I drew the ace of spades, we want to use that frame for our card image game object that we have here. And then we want to go ahead and make it visible. And so to go ahead and do this, the first thing we'll do is we'll update our bottom card in our discard pile to reflect the top card. And so the reason for that is as we add another card on top of our discard pile, we want that bottom one to reflect whatever card was there previously. So as an example, like here, we have this 8 of clubs. Now we have a 2 of hearts, but we see our bottom card image game object is now an 8 of clubs. So to go ahead and do that, let's go ahead and do this. We'll reference our discard pile cards. We'll reference index 0, so for our bottom card, we want to call set frame. And so we want this to match the top card that's currently on top of it. And so we'll reference our discard pile cards. We'll use the first index. We'll grab the frame property. And now we want to make it visible if it needs to be visible. And so now we'll just match our top card. So if our top card is visible, our bottom card will now be visible. So we'll reference our discard pile cards. We'll grab the top one and we'll do visible. Now we want to go ahead and update our top card to match the discard pile card that we just drew from our draw pile. And so we'll do this. We'll do our discard pile cards. We'll reference our first element. We'll reference the next element, so our index 1. Now let's do set frame. And for the time being, we're just going to hard code this to match the back of our card frame. And now we'll go ahead and we'll make our top card visible. We'll go ahead and set equal to be true. All right, so now what we're doing here is, if we go ahead and click on our draw pile, we can see now a card shows up in our discard pile. If we try moving it around, we see there's no card below it. And so what we're doing is, by updating our bottom card to match our top card, our bottom card is still not visible when we draw our first card. Next, we go ahead and update our top card to be visible. So now if we go ahead and draw one more card, what should happen is now we'll have 2 cards in our discard pile. And we can see that now our top card is visible and our bottom card is visible because of the logic we added. All right, so now we have our basic logic for our click events for our draw pile and for moving cards around in our scene with our drag events. Now we want to actually add in our logic for moving our cards between our various card piles. And so what we'll want to be able to do is take our discard pile cards and add it to our tableau, and to be able to add to our foundation. From our tableau, we want to be able to take one card and add it to our foundation, and we also want to be able to take our cards and move them between our various tableau piles. And so to go ahead and implement this type of functionality, we're going to go ahead and add in some new zone game objects, which will be used for detecting when we drop cards in our scene into our various locations. So previously we added a zone game object to listen for our click events for our draw pile, so we go ahead and have one game object detect when we have our click events. And not only can we do this with zones, we can also use them to check to see if an object was dropped onto our zone game object. And to do this, we'll be making use some of the built-in helper methods for our drop zones that will allow us to listen for that drop event. And so to go ahead and start adding this functionality, what we'll do is let's come to our game scene. Let's go into our create method, and we'll make a new method to have all this logic. And so we're just going to call this the create drop zones. And so now what we'll do is let's copy that. We'll come down to the bottom of our class. Let's add in our new method. And so for our method, we won't return anything. And what we're going to want to do is we want to go ahead and create drop zones for our various Tableau card piles so we can drop cards onto it. And we want to go ahead and create a drop zone for our foundation so we can add cards up there as well. So the first thing we'll do is let's go ahead and focus on our foundation. And what we're going to go ahead and do is we'll add a new zone game object up here that's going to overlap our 4 card piles. So let's make a new variable. So we'll do let, we'll do zone, will be equal to this.add.zone. And so what we'll do is we'll do 350 for our x, we'll do 0 for our y, 270 for our width, and we'll do 85 for our height. All right, so now for us to be able to actually listen for drop events on our zone game object, we need to go ahead and tell Phaser to enable that for our game object. And to go ahead and do that, we need to use one of our helper methods, and that's going to be this set rectangle drop zone method. And so what this method does is it allows us to specify a part of our zone game object that we want to go ahead and listen for our drop events on. And so by default for our zone game objects, they do look like a rectangle. And what we can do is we can define part of that area of that game object that we want to enable for drag events. And so as an example, if I only wanted to listen for like events here, we could define that area and then Phaser will go ahead and listen for it there. For our game, we want to go ahead and use our whole game object itself, so the whole width and height of our zone game object for our drop area. And so that's just something to keep in mind when you use this method. You don't have to use your whole game object, you can use a subset of it. And so for us, we're just going to go ahead and use our full width and height that we previously specified, so 270 by 85. And now what we're going to do is we're going to store some data on our zone game object. So we'll use our set data method, and what we're going to do is we're going to add a property, and we're just going to call this zone type, and we're going to set this equal to zone type, and we're going to do foundation. All All right, so what we're doing here is for our zones, we're going to add a field on our data manager to know which type of zone is we're currently interacting with. So when we listen for our events, for our drop events, we'll need to know what type of zone we're dropping our card onto so we can have different logic to handle that accordingly. And so we're going to have two drop zone types. We'll have our foundation and then we'll have our tableau piles. And so for our foundation, when we drop one card onto our foundation, we'll want to go ahead and move that card to the correct pile automatically for the player, so they don't actually have to drop it on each individual card pile. Versus if we're dropping a card onto our tableau piles, we could be dropping one card, we could be moving multiple cards, and we'll have to have different logic to handle that accordingly. And so by adding the zone type, we'll be able to have that distinction when we receive the game object when we receive our zone game object that the drop event is tied to. And so now we need to go ahead and define this. And so for this is just going to be an object with our two different types that we'll support. So what we'll do is let's come to the top of our file. We'll go ahead and add this in real quick. And so what we'll do is we'll do const, we'll do zone type, will be an object, and we'll have two types. We're going to have foundation. So we're just going to copy and paste that. And then we're going to have tableau as our other drop zone type. And so I'm just going to copy and paste that for our value as well. And then I'm going to just do as const. And so then this is like freezing our object so we can't add any additional properties to it. And one last thing I'm going to do is I'm going to go ahead and create a type for this so we can use this in our TypeScript. And so we'll do type, we'll do zone type, will be equal to key of type of our zone type. So what this is going to allow us to do is going to allow us to type our object here, kind of like an enum in TypeScript. All right, so just to see an example, I'm gonna make a new variable real quick. We'll do z. I'm gonna set the type to be equal to our zone type that we just defined. And so now if we hover over it, we'll see now our IntelliSense gives us the exact strings that are available to us as our values from our object here. And so this is gonna be useful once we're handling our drag events. We'll be able to use this type. So what we'll do is let's come back down to our method, and after we create our zone object, what we want to go ahead and do is we're going to go ahead and draw a rectangle to represent this. And so we'll go ahead and do if our debug is enabled. Let's go ahead and add our rectangle. And so for our rectangle, let's go ahead and reference our zone. Let's grab our X position. We'll grab our Y position, and we'll also do that for our width and height. And now for our color, we'll also do red. So we'll do 0x, ff0000, and we'll do 0.2. And let's go ahead and update our origin, and we're going to go ahead and set that to equal to 0. Oh, and we'll also want to go ahead and set our origin on our zone game object. So let's go ahead and add that in, and let's go ahead and save. So now we should see our new red rectangle game object show up in our scene. So now that we have our drop zone for our foundation, let's go ahead and add one for each of our Tableau piles, and then we'll work on adding in our events. So what I'm going to go ahead and do is we actually want this to be let, so we can reuse it. So now let's do a for loop. So we'll do for, and we're going to go ahead and do let I equal 0, I is less than 7, then we'll go ahead and increment it. So now what we'll do is we want to go ahead and create our zone game object. So I'm just going to go ahead and copy this here. We'll go ahead and paste it. And so for our positioning, what we'll want to go ahead and do is we want to go ahead and do 30 plus I times 85. So then that way our zone is going to match up with our card piles here. It'll be based on our X position. Y is going to be the same for each one, so we'll do 92. Now for our width and height, we're going to do 75.5, and we're going to do 585 to take up the rest of the height in our scene. So then we'll do our origin. Now we need to go ahead and do our X and Y here. And so we'll want to match what we just set. So we'll do 75.5, and we'll do 585. And now for setting our data, we want to go ahead and set up our type to be Tableau. In addition to this, we want to know which Tableau our zone game object is actually tied to. So we're going to go ahead and set our Tableau index so we know which one it's referring to. And so we'll add a new field, we'll do Tableau index, and we'll set equal to I. So now we want to go ahead and draw our rectangles so we can actually see them. So let's go ahead and paste this. And now we want to go ahead and we'll go ahead and update our alpha to be 0.5. Oh, and so this shouldn't be 30 plus 1. This should actually be 30 plus I times 85. All right, so now if we go ahead and save, we'll see now we have our 7 red rectangles show up. And so we have our 7 zone game objects representing our Tableau. All right, so one last thing we need to do is for our drop zone game objects, we need to go ahead and update the depth on them. So if we try clicking on our cards in our current piles, we'll see that we're not actually able to click on them. And so by default, when we register our event listeners on our game objects, our click events will always go to the topmost game object, and we won't be able to actually click on the game objects under it unless we tell Phaser to go ahead and ignore and allow that event to propagate to those other game objects. And so what's happening is because our zone game object is now on top of our cards, even though it's transparent, our events aren't able to get down to our cards. So what we're going to go ahead and do is we're going to update our depth on our drop zones to go ahead and be a -1. So then that way we can listen for our click events on our cards, but we'll still be able to listen for our drop events when we move our game objects around. So what we'll do is we'll do set depth, and we'll go ahead and set this equal to be -1, and then we'll go ahead and save. So now if we try clicking on our cards, we'll see now that they appear on top of our zone game objects, and we can actually still move them around. So now that we have our drop zone game objects, what we need to do now is we need to create our event listener so we can listen for those drop events. So what we'll do is let's go to our method where we create our event listeners, and let's add a new method, and we'll do this. We'll do create drop event listener. And so what we'll do is let's copy this. We'll go ahead and add a new method to our code. So come to the bottom of our class, let's go and add in that method. And so we won't return anything, so let's add in void. And now what we want to do is we want to go ahead and listen for input on our input plugin. And so we'll do this, we'll do our input, we'll do on. And so now for our event that we want to listen for, we're going to go ahead and do Phaser. We're going to go ahead and do our input, events, and now let's go ahead and do our drop event. And so for our drop event, let's go ahead and provide our callback function that'll be invoked. And so for this callback, when it's invoked, we're going to go ahead and get 3 arguments. Our first one is going to be our pointer game object. And so this will be our Phaser, our input pointer. Next, we're going to go ahead and get the game object that we currently dropped as part of that event. Let's go ahead and add in game object. For our type, we know this will be an image game object. And then finally, we're going to receive the drop zone that we drop the game object onto. So we'll add in drop zone, and so this will be a Phaser game objects, and it's going to be a zone game object. So now what we'll need to do is we're going to need to grab that zone type value that we added to our data manager for our zone game object, so then that way we can go ahead and know where we're trying to move our card to in our game. So to go ahead and do this, let's go ahead, we're going to store this in a new variable. So we'll do const, let's do zone type. We're going to set it equal to our drop zone game object. We'll use the get data to reference our data manager. We'll want to go ahead and grab our zone type value from our data manager, and we're just going to go ahead and type this as zone type. And so we know that we added this to each of our zone game objects, so we should get this from our data manager. So now what we're going to do is we're going to check that type. So if our zone type is equal to our zone type, if it's foundation, we're going to go ahead and call a new method to handle that logic. So let's go ahead and add that in. So we'll do this. We're going to do handle move card to foundation. And so we'll go ahead and pass in our game object that's currently being moved, and we'll go ahead and return. If it's not our foundation, then we know we're trying to move it to one of our Tableau piles. And so what we'll do is we'll call a new method to handle that as well. And so for this, we'll go ahead and add a new method. So let's do this. We'll do handle move card Tableau. And so for this, we'll have our game object. We'll also need to know which Tableau index we're trying to move our card to. And so what we'll do is let's go ahead and add in that variable, and we'll need to grab that from our data manager. So let's copy this, we'll go ahead and paste, and change this to have our variable be Tableau index, and we'll grab that from our data manager. And so for this is going to be a number. All right, so now what we'll need to do is let's go ahead and define those 2 methods. So let's just copy this. Let's add our new private method to our class, and we'll do void for our return type, and we'll copy this one. We'll do the same thing. So now what we need to do is let's go ahead and add in our arguments that we expect. So we're going to have our game object. So this is going to be a Phaser game objects image for our type. And we'll go ahead and copy. Let's go ahead and paste that here. And then we'll also be expecting our Tableau index. So we're just going to call this target Tableau file index, and there'll be a number. So what I'm going to do for both of our methods is I'm just going to add a console log just so we can make sure our logic's working. So let's do console log, and we'll do placed card on foundation. I'm going to copy that. Let's go ahead and paste it, and we'll say place card on Tableau file, and we'll also do our target Tableau file index so we know we're trying to move our card. So now what we should be able to do is if we grab one of our cards and if we try to move it from one Tableau pile to another, we'll see our logic invokes, and we'll see place card in Tableau pile 2. If we just move the card to the same pile, we have the same index, and we can see that our logic's working how we expect. And if we take a card and try to add it to our foundation, we see that's working as well. All right, so then we go ahead and try our draw card pile. Let's go ahead and add a card to our discard pile. And if we try to move it to one of our tableaus, we can also see our logic's working. And if we try to drop it onto our foundation pile, we get our message. All right, so with our new drop zone game objects in place, and we have our logic for our drop events, the next thing we want to do is we want to start adding in some stub logic to validate when we try to move our cards around our scene to actually leave our cards in our new location if the move was valid, and if it's not valid, we want to go ahead and have it snap back to its previous location. So for the time being, what we're going to end up doing is we're going to hard code part of this logic, but we're going to try to set up the structure we're going to need for once we actually have our Solitaire game logic. And so to get started, we'll focus on playing cards from our discard pile to our tableau and foundation card piles. And so when a card from our discard pile is placed onto the foundation or tableau, if the move is not valid, we want to go ahead and put that card back on top of our discard pile. If it is valid, we want to go ahead and update those piles to have that new card. And so to get started with this, the first thing we're going to do is we're going to create a new class that's going to represent our core Solitaire game logic. And by creating this class now, we'll be able to define the interface for how we're going to interact with this class. And we'll just go ahead and hard code our values that are returned. And so in this class, we're going to add methods for placing cards onto our various piles. And we're going to return a Boolean value if the move was valid or not. And so to go ahead and do this, we're going to go ahead and make a new folder under our source folder. We're just going to call this lib. And what we're going to do is let's make a new file. And we're going to call it Solitaire. And we'll do .ts. And so we're going to go ahead and put all this inside of a class. So let's do export class, and we're just going to call this Solitaire. And now what we'll do is we're going to go ahead and define our public methods that we're going to expect on our class. And so the first one is we're just going to do new game. And what this method will be used for, it's going to be used for setting up our Solitaire game and for resetting all of our cards and then basically dealing our cards out into our various piles. Next, we'll want to go ahead and have a method for being able to draw cards. So I'm just going to copy and paste this. We're going to call this draw card. And so on this method, we want to go ahead and return a Boolean value if we're actually able to draw cards. And so we're just going to do return true. So in this method, this will be used for drawing cards from our draw pile. And if our pile is empty, we actually return false. If it's not, we'll go ahead and return true, and we'll place that card onto our discard pile. Next, we'll add a method for shuffling in our discard pile into our draw pile. And so we'll do shuffle discard pile. And so this is going to be used for once our draw pile is empty, we'll add our cards from our discard pile back into our draw pile, and we'll return true if we do this. If our pile is not empty and we don't need to actually shuffle, we'd return false. Now we're going to go ahead and add in our methods for actually playing our cards to our various piles. And so what I'm going to do, I'm going to paste this 2 more times. And so for our first one, we're going to do play discard pile card to foundation, and we'll also do play discard pile to tableau. So when we play our discard pile to our foundation, we'll return true if valid, false if not. When we play it to our tableau, we'll need to know which tableau we're trying to add it to. So we're going to do our target tableau pile index. This will be a number. Likewise, when we play our card, we return true if it's a valid move. So now we want to go ahead and have our 2 methods for moving our cards between our tableau and our foundation or our other tableau piles. And so I'm going to go ahead and do is I'm going to copy these 2 methods here, go ahead and paste them here. And we'll go ahead and change our name to be move tableau card to foundation. And so for this method, we'll need to know which tableau pile we're trying to take our card from. And so let's go ahead and add in our tableau pile index. This will be our number. And so for our next method, we'll go ahead and do move tableau cards to another tableau. And so for this method, when we try to move our cards between our various piles, we'll need to know which tableau index our card is coming from. We'll need to know what the card index is so we know how many cards to move. Then we'll need our target tableau for where we're placing our cards. And so for this, we'll have our target tableau pile index. We'll go ahead and add in initial tableau index, which will be a number. We'll have our card index, which will also be a number, and we'll go ahead and save. So one last method we're going to add is we're going to add a method for knowing if we need to go ahead and flip over the bottom card in one of our tableau piles. And so as we move our cards around, we want to go ahead and flip over the next card in our stack, so then that way our player can go ahead and use that card and start using it right away. So to do that, I'm just going to copy this here. I'll go ahead and paste this. And for our method name, we'll say flip top tableau card. And so we'll have our tableau pile index, and we'll go ahead and return true. All right, so all we're trying to do for the time being is we're just to define the structure of our class and what our public methods will be. So then that way we can now start updating our game scene to call those methods, and we can use it for creating our structure for after we drag and drop our cards. And so then what we'll do for testing our functionality is we'll have our hard-coded true values inside here, and then we'll toggle them to be false when we want to test if our card move was not valid. And so now that we have our new class, we need to go ahead and create an instance of this in our game scene. So what we'll do is we'll come to the top of our class, and what we'll do is let's go ahead and add in our Solitaire instance. Let's make a new private property. We're going to call it Solitaire, and we'll go ahead and type this to be our Solitaire class. So then what we'll do is in our create method, let's create an instance of this. So we'll do this Solitaire will be equal to a new Solitaire instance. And let's go ahead and call our new game method to go ahead and set up our game. And so right now, nothing will happen in our class, but this is the logic that we'll expect when we start our scene. All right, so now we have our Solitaire game instance. What we need to do next is now we're going to work on updating our handle move card to foundation method. And so inside this method, we'll need to keep track to see if a valid move was actually made. And in addition to that, we're going to need to know if our card actually came from our discard pile or from one of our Tableau piles. And so to do that check, we're going to rely on our data manager for our image game object. And if it has that pile index property set, then we know it came from the Tableau. So what we're going to go ahead and do is let's get rid of our console log. Let's make two variables to keep track of these two properties. And so we'll do let, and we'll do is valid move. We'll go ahead and set equal to false. And we'll do let is card from discard pile. And we'll go ahead and set that equal to false. So go ahead and check to see if it's actually from our discard pile. We need to go ahead and grab our pile index from our data manager. So let's make a new variable. We'll do const. We'll do Tableau pile index will be equal to our game object. And we'll use our get data method. And we want to go ahead and grab our pile index from our data manager. And so this is either going to be a number or it's going to be undefined. And so if it's undefined, then we know that this came from our discard pile. And so what we'll go ahead and do is we'll do is card from discard pile, and we'll go ahead and set that equal to true. If it's not undefined, then we know that it came from our Tableau. And so now what we want to do is now we want to go ahead and call our methods that we defined inside our class here to check to see if the move was actually valid. So what we're going to go ahead and do is we're going to go ahead and do is valid move. We're going to set that equal to our Solitaire game instance. And we're going to go ahead and do move. We're going to do play discard pile to foundation if it came from our discard pile. Otherwise, we want to go ahead and call our other method for moving a card from our Tableau to our foundation. And so we're going to do move Tableau card to foundation, and we'll pass in our Tableau pile index from our data manager. All right, so up to this point, all we've done so far is we've just updated our isValidMove variable. And so this variable is going to be used for tracking if this is actually a valid move in our game. And all we're doing is we're just calling our stub methods inside our Solitaire class. And so we'll be working on adding this logic next, but for the time being, we just want to simulate that this was a valid move in Solitaire. And then that way we'll update our game objects to be in the correct position after we move our cards. And so now the next thing we need to do is in our method, we need to make sure that our move was actually valid. And if our move was not valid, we want to go ahead and just return early from our method. And the reason for that is we're going to rely on our logic in our drag in event handler to go ahead and move our cards back to the original location like what we're doing right now. If the move is valid, then what we need to do is, depending on where the card came from, we need to do different things. If our card comes from our Tableau, we want to go ahead and update our frame on one of our foundation piles, and we want to go ahead and destroy this card image game object because we'll no longer need that card in our game. If the card comes from our discard pile, we want to go ahead and update our frame here, but not destroy this game object because we're just going to reuse it. We just need to go ahead and update the frame to match the next card in our discard pile. And so to go ahead and do this, we're going to add a few new methods to have this type of functionality. So first thing we're going to do is we're going to check to see if our card is from our discard pile. If the card's from our discard pile, we're going to call a new method, and we're going to call this update card game objects in discard pile. And if it's not from our discard pile, then we want to go ahead and call another new method, and we're going to call this one handle revealing new tableau cards. And so for this method, we'll need to pass in our tableau pile index. So then that way we can use that to update the correct container. So then what we'll do is let's go ahead and add in these new methods. So I'm just going to add these to the bottom of our class. And so for both of these, we'll just return void. And we'll go ahead and add in our argument for our tableau pile index. It'll be a number. Next, what we'll want to do is if our card did not come from our discard pile, we'll want to go ahead and destroy it. So what we'll do is if this card is not from our discard pile, we'll go ahead and do our game object. We'll call the destroy method on it to go ahead and remove that game object. And then finally, what we'll need to do is now we need to go ahead and update our game objects inside our foundation pile here. And so to do that, we'll also make a new method. So we'll do this, we'll do update foundation files, and then let's go ahead and add in that method to our class. And so for this method, we'll also return nothing. All right, so for our 3 methods that we just added, so for 2 of them, we're just going to add to-dos, so we'll come back to those shortly. And so in our update card game objects and discard pile method, we want to do logic similar to what we did in our click event listener for when we drew our cards. Basically what we want to do is we want to update our top card to match the bottom card game object by updating its frame and the visibility. And then we'll need to update our bottom card to actually be visible or not based on our game state. And so once we add in our logic for our Solitaire class, we'll have our bottom card game object be based on that. And so for the time being, we'll go ahead and hard code this. And so to do this, we'll do our discard pile cards. Let's grab our top one. Let's call set frame. We need to go ahead and match our bottom card. So we'll do this, our discard pile cards, index 0. We'll reference the frame. Then we'll go ahead and call set visible. And we'll go ahead and do similar logic here. So let's just copy this. Let's go ahead and paste that. And we're going to change this to be visible. Now we want to go ahead and update our bottom card, and so we'll do discard pile cards, 0, and for the time being, we're just going to go ahead and do set visible, and we're going to hard code this to false. All right, so now what we should be able to do is in our code, if we draw some cards, if we drag our card from our discard pile to our foundation pile, we'll see now our cards are updating, and if we drag cards from our tableau pile, we are now destroying the card game objects, and we're moving them from our tableau piles. All right, and so one other change we need to do is now that we're destroying our game objects, we need to go ahead and update our event listener for our drop event to make sure our game object is actually still exists and still active before we try resetting its position. So what we'll do is let's come up to our create drag end event listener. And before we call our set alpha or our set position, we just want to make sure our game object is still active. And so if we do an if statement, we'll do if game object is active, then we want to go ahead and do all this logic that we defined here. If the game object is not active, then we go ahead and ignore it. And so when we call the destroy method, internally Phaser is going to go ahead and set active to be false while it's cleaning up the game object. And by adding this safeguard, we'll make sure that we're not trying to update a game object, we're trying to remove from our scene. All right, so now we have our base logic in place for placing cards on our foundation pile. We need to add similar logic for placing cards onto our tableau piles, and we're going to do this in our handle move card tableau method. And so what we need to do, first we need to check to see if the card is coming from our tableau pile or from our discard pile, similar to what we just did. And once it's determined, we're going to check if our card movement is valid, and then we'll go ahead and move the card or cards to the correct tableau stack. So go ahead and do this. Let's go and get rid of our console log. And what we'll do is I'm going to go ahead and copy part of this logic here where we do from our move card to foundation. Let's go ahead and paste it. And so if the card is from our discard pile, we want to go ahead and call our play discard pile to tableau. And for this, we'll need to go ahead and pass in our target tableau pile index of where we're trying to move our card to. If it's not from our discard pile, then we need to go ahead and call our move tableau cards to another tableau. And so for this, we'll need to go ahead and grab our tableau pile index, which we're already doing from our data manager. We'll also need to grab our card index, and we need to go ahead and pass in our target tableau pile index of where we're trying to move the cards to. And so to go ahead and grab our card pile, let's go ahead and copy this. We'll go ahead and paste it. Let's go ahead and change this to our card index. This will be a number, and we'll go ahead and change this to be tableau card index, and we'll go ahead and pass that in. And so now what we'll want to do, if our move's not valid, we will go ahead and return early like we did before. So let's go ahead and paste that. And so now if the move is valid, what we'll need to do is if the card's coming from our discard pile and we're trying to place it onto a tableau, we need to create a new card image game object, and we need to place that into the appropriate container. And then we need to go ahead and update our discard pile to show that we removed a card from here. If the card is from one tableau or multiple cards from one tableau to another, we need to remove those from that container and then place those into the new container for our tableau that we're adding it to. So go ahead and do this logic. Let's go ahead and start with our discard pile. So we'll do if it's card from discard pile. We want to go ahead and create a new card image game object. And so we'll do const, we'll do card, be equal to this, we'll do create card. And now we need to specify our positioning. And so we'll do 0 for our X. And so for our Y value, we're going to need to know how many cards are currently in our tableau pile that we're adding the card to. And so then that way our Y value will put the card into the correct position on our stack here. So to get that value, what we're going to do is let's make a new variable at the top of our method. We'll do const and we'll do original target pile size. And so by doing this before we do anything else, we'll actually know the size of the pile before we add any cards to that container. And so we'll reference our Tableau pile containers. And now we want to grab our target pile, our target Tableau pile index, and we want to grab the length. So now what we can do is for our Y value, we can go ahead and use that variable and we can go ahead and multiply it by 20. So then that way we know what the current size is, and the new card will be down 20 pixels from that last card. Now we'll want this to be draggable because this card is visible to the player, so we'll be able to move it around our scene. And now we want to go ahead and pass in our card index and our pile index. So for our card index, we're going to use that original size because since it's a zero-based index, if we use the value of the current length, that'll be the next index when we add a card. And now we want to go ahead and pass in our target Tableau pile index for which tableau we're adding the card to. So after we create our card game object, we need to go ahead and update our frame to match the card that we just moved. And so we'll do our card and we'll do set frame. And what we'll do is we're going to reference our game object and grab the frame property from it. Next, we want to go ahead and add that card game object to our relevant container. And so to go ahead and do that, we'll reference our Tableau containers. We're going to reference our target Tableau pile index to grab the correct container. We'll use the add method to add our image game object. So finally, now we want to go ahead and update our cards in our discard pile. So we'll also call that update card game objects in our discard pile method so we can update our game object accordingly. And then we'll go ahead and return early since we don't need to do our other logic. So now, if we go ahead and test, if we go ahead and draw a couple cards, if we take one of our cards and add it to one of our Tableau piles, we'll see now our new card is being added to the container, and now it's being stacked on top of our other cards. And now we can go ahead and click and drag those cards around our scene, and we can go ahead and move those cards as part of our stack. All right, so if the card is not from our discard pile, then what we need to do is we need to determine how many cards are currently being moved, and then we want to move all of those card image game objects to the new container when our move is valid. And so to go ahead and do that, we're going to go ahead and call our method for calculating the number of cards we need to move. So do const, we'll do number of cards to move will be equal to this, get number of cards to move as part of our stack. Let's go ahead and pass our Tableau pile index. And then we want to go ahead and pass in our Tableau card index as well. And so at this point in our code, we know this is not undefined, so we'll go ahead and pass it as a number. So now what we need to do is we need to loop through all those cards, plus our current card image game object, and move them all to our new container. So what we'll do is let's make a for loop. We'll do let I equal 0, and we'll do I is less than or equal to our number of cards to move. We'll go ahead and increment. And so what we're doing here is by making this 0, we'll make sure we move at least the one card that we're currently dropping. And if there's more cards we need to move, we'll also catch those as well. So now what we want to do is we want to get a reference to that card game object from our container. We want to go ahead and remove it from the existing container and then add it to the new container. And so to get a reference, let's make a new variable. We'll do card game object. We'll set it equal to our Tableau containers. And we'll use our Tableau pile index from where our card came from. And so we'll type that as a number. And now we want to use the getAt method, and we want to go ahead and we know this is going to be an image game object. So let's just type that. We'll do phaser gameObjects.image. And now we want to use the Tableau card index that we grabbed from our card. All right, so now we have a reference to that card. We can go ahead and remove it from the current container. So what I'm going to do is I'm going to copy this part of our code right here. So this is going to grab us the container that our card game object is currently inside. And we're going to use the removeAt method to remove a game object from our container at a specific index. And so for our index, it's going to be our Tableau card index that we grab from our game object. So now what we want to do is we want to go ahead and add that to our new container. And so we'll reference our Tableau containers. And so now we'll want to go ahead and use our target Tableau pile index. So the Tableau pile we're trying to add to, and we'll use our add method, and we'll go ahead and use our reference to that game object. All right, so now what we want to do is now we want to go ahead and update our data in our data manager, because since we're moving our cards between our piles, we'll need to update our X and Y position. We'll need to update what the new index of the card is and what the new pile index is as well. And so go ahead and do this. Let's go ahead and reference our card game object. Let's call set data. And now we're going to go ahead and pass in our object of the keys and values you want to go ahead and store. So for X, we'll go ahead and do 0 since we're using container's position. Next, we'll go ahead and do our Y. And so for our Y value, this is going to be dependent on where the card is now at in our stack. And so for this, we'll make a new variable. We're just going to call this card index, and we're going to multiply it by 20. So then that way the card moves down our stack. Then we want to go ahead and set our card index itself. So we'll go ahead and do our shorthand. And now for our pile index, we want to go ahead and use our target Tableau pile index so we have the correct container. So now for our card index, let's make a new variable. We're going to set it equal to our original target pile size. And we're going to go ahead and increment it by I. All right, and so before we test, we need to go ahead and fix our code. So this shouldn't be card index. This should actually be our Tableau pile index that we're grabbing. And so this will be as number for our type. All right, so real quick before we test, we got two other things we need to do. The first is we want to go ahead and reset the depth on our container after we finish moving our cards. So that way it's back to its original value. And so to do that, we'll do our Tableau pile containers. We'll do our Tableau pile index as number, and then we want to go ahead and set depth, and we'll go ahead and set it equal to 0. Next, we'll want to go ahead and handle revealing the next card in our stack if we remove our cards from our stack here. And so we'll go ahead and call our new method here. And so let's just go ahead and call our method, and let's go ahead and pass in our Tableau pile index. All right, so now we're going to save. We should be able to test our changes. So if we try moving one of our cards from our Tableau to another Tableau, we can see we move one card. We grab multiple cards. They're now all moved from our one pile to our other pile. All right, if we want to go ahead and test if our moves were not valid, what we're going to go ahead and do is we're going to go ahead and update our logic in here to go ahead and just return false for various methods that we want to test. So what I'm going to do is I'm just going to set this to false for playing our discard pile to our foundation in Tableau, and for moving our card from our Tableau to our foundation and to another Tableau. So if we do that, what we should be able to do now is if we try dragging our cards, we'll see that the move is not valid, and we place all of our cards back in the correct piles. Same thing if we do our discard pile, it snaps our card back to our discard pile's location. All right, and so what I'm going to go ahead and do is I'm going to revert those back to true. I'm going to go ahead and save. All right, so now we have our core logic in place for handling our player input in our game. Now we need to go ahead and start building out our core Solitaire library that we'll be using for having our actual logic for our game. And then what we're going to do is we'll go ahead and tie that to our game scene and finish up our additional methods. And so to get started with building our core logic, what we're going to do first is we're going to go ahead and work on creating our types and our data models to represent our actual deck of cards. And so in the game of Solitaire, we're going to use a standard deck of 52 cards. We're just going to have the following attributes. A single card, we're going to have two colors, it's going to be red and black. There's going to be 4 card suits. We're going to have our spades, our clubs, diamonds, and hearts. And all the cards that are hearts or diamonds are the color red. All of the cards that are spades or clubs will be the color black. For each suit of cards, we're going to have 13 cards. We're going to have the ace, which will be number 1. We'll have the numbers 2 through 10. Finally, we'll have a jack, queen, and king, which is going to represent 11 for the jack, 12 for queen, 13 for king. And so each card will either be in one of two states. It's either going to be face up or face down. And so when a card is face down, we're going to show the player the back of our card frame, and the player's not going to be able to drag those cards around our scene. If the card is face up, then we're going to show the correct card frame, and the player will be able to drag those cards around as long as that card is not in our foundation pile. So to get started with modeling our deck of cards, the first thing we're going to do is let's make a new file in our lib folder. And so what we're going to do is we're going to make a new file. We're going to call it common.ts. And so what we're going to do is first let's go ahead and define our card suits. So let's do export const. We'll do card suit. And so for our suits, we'll have our 4 suits. So we'll have hearts, diamond, spade, and then we'll have a club. Now for each of our values on our object, we'll go ahead and have the same value. And then for our object, we'll do as const. So let's go ahead and add our type for our card suit. So we'll do export type, card suit will be equal to key of, type of, card suit. And so next we'll go ahead and add a type for our card values. And so instead of just doing a number, we're actually going to restrict this to the range of numbers that we know we support. So we'll do export type, we'll do card value. And so this is going to be 1 through 13. So we'll do 1 or 2 or 3. And we'll repeat this until we get to 13. Next, we want to go ahead and do our suit color. So I'm just going to copy these lines of code here. I'm going to go ahead and paste it. And so we're going to have our card, suit, and then color. And so we'll have black and red. So let's update our values. And let's go ahead and update our type. And so we're going to have card suit color will be the key of type of card suit color. All right, so the last thing we're going to add to our file is we're just going to add a mapping between our card suits to the appropriate card color. And so we're going to store this on objects. We'll do export const, and we'll do card suit to color, so they equal to an object. And so now we want to do each of our various card suits. And so I'm just going to copy this here. We're going to paste it. Now for our card suits, we're going to have this be dynamic based on this here. And so I'm just going to copy this. We'll do card suit.heart, card suit.diamond, card suit.spade, and card suit.club. And so for our keys to be dynamic like this, we need to go ahead and wrap them in brackets. So then that way we can reference our variables to create the appropriate key. So now for our colors, let's go ahead and do our card suit color, and we'll go ahead and do red for our heart and diamond. So let's just copy this. We'll go ahead and paste it. And now we're going to do black for our other 2 suits. Then let's do as const, so then we can't modify our object. All right, so the next thing we're going to do is we're going to create a class to actually represent our card instance. And so on our card, we're going to have 3 primary properties. And it's going to be our suit, our value, and if the card's face up or not. And then what we'll end up doing is we'll have our deck of cards consist of multiple instances of our card object. And so what we'll do is let's make a new file, and we're just going to call this card.ts. Let's export out our class. We're going to call it card. We're going to have 3 properties. Let's do suit. So this is going to be our card suit type. We're going to have value. So this will be our card value type. Then finally, we're going to have face up. And this is going to be a Boolean. Let's go add in our constructor. So when we create an instance of our card, we'll need these values. And so we'll have suit. We'll have value. That'll be our card value type. And then finally, we'll have is face up. And we're going to add a default value of this. We'll set equal to false so we can pass this in. So now let's go ahead and update our private properties to have the correct values. We'll do this is face up. We'll do this face up is equal to is face up. The suit will be equal to suit. This value will be equal to value. And so on our card, we're going to go ahead and add some getters. We can actually return these properties. So we'll do get. Let's go ahead and do suit. We'll return a card suit. And so we're going to return this suit. And we'll want to do the same thing for value and is face up. So I'm just going to copy this. We'll paste it twice. And so we're going to have value, and we'll do is face up. And let's go ahead and update our types and update our references. So we'll return this value, and we'll return face up. 2 other things we're going to do is we're going to go ahead and add a getter to return our color for our card. And then we want to go ahead and add a public method to allow us to flip our card over. So let's go ahead and set face up equal to the opposite value. So let's do get color. For this, we're going to return our card suit color. And we're just going to return, we'll use that object we created, our card suit to color. And we'll pass in our suit for our key. That we return our color. And now let's do public. We'll do flip So for this method, we won't take any arguments and we won't return anything. And we'll go ahead and do this. Face up will be equal to the opposite of what it's currently set to. So now that we have our object that represents our cards, next thing we do is we need to create a class to represent our full deck of cards. And so for our full deck of cards, we're going to need the following functionality. We'll need to be able to create our deck, which will consist of 52 unique cards, 13 cards in each suit. So for our deck of cards, we'll need to have a discard pile and a draw pile. We'll need to have the ability to draw a card from our draw pile. And finally, we need to be able to shuffle our deck of cards and re-add the cards from our discard pile back into our draw pile. And so basically we're just modeling what an actual deck of cards is and how we can actually interact with it. So to go ahead and do this, let's make a new file, and we're going to call this deck.ts. Let's export out our class. And so now for our deck, we'll need an array to keep track of our cards that make up the deck, and we'll need arrays to keep track of our draw and discard piles. So first let's do cards. So for our cards, this will be a card array for our type. Next we'll have our draw pile. This will also be a card array, and then we'll have our discard pile, which will also be a card array. So now let's go ahead and create our constructor. So when we create an instance of our deck, we'll go ahead and set our cards to be an empty array, and we'll do the same thing for our draw and discard piles. I'm just going to copy this, paste it twice. So our draw pile will be an empty array, discard pile will be an empty array. All right, so then what we want to do is now we actually want to construct our deck of cards. And so to go ahead and do this, we're going to store this in a new method that we can use for being able to reset our deck. So what we'll do is we'll make a new method, and we're just going to call it reset. And we'll go ahead and call that. So let's add our public method. So we'll have reset, and we won't return anything for this. And so when we reset our deck of cards, what we'll want to do is we'll want to go ahead and reset our discard pile to be empty again. We'll want to have our draw pile have all of our cards in it, and then we'll want to go ahead and shuffle it. So what we're going to go ahead and do is let's go ahead and update our discard pile to be empty. To put all of our cards into our draw pile, we'll go ahead and do this. We'll do our draw pile will be equal to, and we're just going to go ahead and copy the objects from our other array. And so we're just going to go ahead and copy this .cards. Now we want to go ahead and shuffle. And so to go ahead and do this, we'll make a method to have this logic. So let's go ahead and add our public method. So we'll have public, we'll have shuffle. And so on this method, we won't return anything. And then for actually shuffling our cards, what we'll do is we're going to create a utils file that'll have this functionality. And so what we're going to do is we're going to call a function to do this. We're just going to call it shuffle array, and we'll pass in our draw pile that we want to go ahead and shuffle. And so we'll come back and add this function in a second. We're going to focus on finish defining our deck of cards. All right, so on our deck of cards, we're going to need a way to go ahead and grab what cards are tied to our deck and which cards are tied to our draw and discard piles. So what we'll do is we'll create 3 getters. So let's do get cards. This is going to return an array of cards. And so we'll return this in our cards property. Let's copy this. We'll paste it twice. And so let's go ahead and do our draw pile. And we'll update our reference. And then we'll do our discard pile. And we'll update our reference. So besides these 2 public methods, we'll also need a way to draw our cards. So let's go ahead and do public. We'll do draw. And so this will return a card instance or undefined if there's no cards we can draw. And so what we'll do is we'll return this. We'll reference our draw pile. And we'll call the shift method to go ahead and remove that element from our array. All right, so one other public method we're going to need is we'll need a way to shuffle in our discard pile. And so for our discard pile, we just want to take all of the cards from our discard pile and go ahead and add those back into our draw pile. And so what we'll do is do public, we'll do shuffle in discard pile. This method won't actually return anything. And so to do this, we're going to reference our discard pile. We're going to use the for each method to iterate through each card. And so for each card, we want to go ahead and flip this back over to, so that way it's face down. And so we'll do card.flip. And then what we'll do is we'll add these to our draw pile. So we do this draw pile, we'll do push, and we'll add our cards back in. Finally, we'll go ahead and make sure our discard pile is now empty. And so we'll go ahead and set it equal to an empty array instance. All right, so now we have our public methods and our getters. Now we actually need to go ahead and create our deck. So for creating our deck, we need to go ahead and create new card instances for each of our card suits and for each of our values. So to do this, let's make a new private method, and we're going to do create deck, and we'll do void. And so we're going to call this method from our constructor right before we do our reset. And so we'll do call this.createDeck. So now inside here, what we want to do is we need to go ahead and create our 52 card instances. And so to do that, we're going to grab all of our values from our card suits. And then for each of those suits, we'll create our card instances. So to do that, we're just going to do object.values to grab all the values from one of our objects, and we'll use our card suit object. And now that this will return an array of those values, and so now we can use for each. And so for each of our strings, our card suits, we want to go ahead and create our 13 card instances. And so for this, we'll do an inner loop. So we'll do for let I equal 1. I is less than 14. Then we want to go ahead and increment I. And so for each iteration, we'll want to go ahead and use that as our value. And so we'll do this.cards, and we'll do push. And so we'll create a new card instance. And so we'll pass in our suit. We'll pass in I as card value. All right, so now that takes care of modeling our cards. And the last thing we need to do is now we need to actually define our shuffle array. So what we're going to go ahead and do is let's make a new file. And we're going to call this utils.ts. And let's go ahead and export out a function. And we're going to call this shuffle array. All right, so when we shuffle our array, we won't actually return anything. We're going to do an in-place shuffle. And so to do this, we'll need one argument. It's going to be the array that we want to go ahead and shuffle. And so for this, it's going to be some type of array. And so instead of typing it as any, we're going to use T, and we'll go ahead and provide that. So what that's going to allow us to do is when we call shuffle array, whatever type we provide, we'll be able to use that. All right, so for actually shuffling our cards, what we're going to do is we're going to use a common algorithm called the Fisher-Yates shuffle. And so this is a common algorithm that allows us to do a shuffle in place. And so it's really efficient, and basically at a high level how it works, what we're going to do is we're going to iterate through our array in reverse, and basically we're going to move elements in our array around based on a random value. And so this is actually really easy to code, and so what we're going to end up doing for our code is now we just need to iterate through our array, calculate a random value, and basically just move our elements around. So what we're going to do is we're going to do a for loop. We'll do let I equal our array.length. And then what we'll do is we want to subtract 1, so we have our 0-based index. If I is greater than 0, we want to go ahead and decrement this, so that way we're going through our array in reverse. So now we need to go ahead and calculate our random value, so let's just do const j will be equal to math.floor, and we're going to do math.random, and so we're going to times that by I. So now we have our random value, and now we need to store a reference to our element in our array. So we're going to make a new variable to do that. We'll do const temp be equal to our array, our I index. And now we just need to swap those two around. And so we'll do array I is going to be equal to array j. And now we'll do array j is going to be equal to temp. So basically all we're doing is we're just looping through our array in reverse, and then whatever this index is, the last element at that time, we're going to go ahead and store that in a temporary value, so then that way we have a reference to it. And now we're just going to update our references in our array to swap our values. So now we can do back in our deck class. So what we can do in our method is let's go ahead and update our function so we can update our import. All right, so one last thing we need to do before we jump into our Solitaire class is we're going to create a class to model one of our foundation piles. And so for our foundation piles, we'll need to have the ability to support the following functionality. We'll need properties to keep track of what card suit is assigned to that pile and what the current value of that pile is. And then we'll also want to have methods to go ahead and reset the initial value and to add new cards to the foundation pile. So to do this, let's make a new file, and we're going to call this foundation pile.ts. Let's export our class, export class, foundation pile. And so now for our properties, we'll have our suit, which will be a card suit, and then we'll have our current value. And so for this, we want to go ahead and have it be our card value or the value 0 when we first create an instance of our foundation pile. So let's go ahead and add in our constructor. And so we'll do, for our arguments, we'll expect a suit, which will be our card suit. So we'll go ahead and do this. Our suit will be equal to the suit, and we'll have this current value be equal to 0. So now we'll go ahead and add some getters for these two properties. So we'll do get suit. We'll return this.suit, and now we'll do get value. So we'll go ahead and return our card value or 0. So we'll return this current value. So now we want to go ahead and add our two public methods, and so we'll do public reset. This won't return anything. And so for this, we'll just go ahead and update our current value to be 0. Now for adding a card, do public, add card. We won't have any arguments, we'll return void. And so now what we're going to want to do is we want to go ahead and increment our current value. And if we're already at our max, so 13, we won't actually do anything. So we'll add a safeguard do if our current value is already equal to 13. We'll go ahead and return. If it's not equal to 13, then let's go ahead and increment it by 1. And so this is going to simulate if we add a card to our foundation pile, it'd be like the next card be showing up there. So now with our foundation pile class created, that actually wraps up our classes and our models and types that we're going to use to represent our deck of cards and other types we need for the game Solitaire. So now we're going to go ahead and switch back to our Solitaire class, and we'll start adding in our actual functionality for our various methods that we defined before. So for our Solitaire class, the first thing we're going to do is we're going to create some new private properties to go ahead and track some of the piles we'll need for our game. And so we'll need to keep track of our deck of cards, our 4 foundation piles, and then our tableau piles that are used in our game. And so to go ahead and do this, let's go to the top of our class. First, let's go ahead and add in our deck. And so for our type, we'll have our deck. Next, we'll have our 4 foundation piles. And so we'll have foundation, and then we'll do pile, and we'll do spade. For our type, it'll be foundation pile. I'm going to go ahead and copy that, and we're going to do this 3 more times. 1 for each of our different suits. So then we'll have clubs, hearts, and then we're going to have diamonds. And then next, we're going to go ahead and create our tableau piles. And for this is just going to be an array of arrays, and that'll have a type of card. And so we'll have our tableau piles, and it'll be card array. So now what we'll do is go ahead and add our constructor, and we'll go ahead and initialize these. And so start with our deck. So we'll set equal to a new instance of our deck class. Then we'll go ahead and do our foundation piles. And so we'll have our club foundation pile be equal to a new foundation pile. And so for this, we'll have our card suit. So we'll reference our object, and so we'll do card suit, and we'll do clubs. I'm going to copy this line, and we'll add our other piles. Then we'll have spades, hearts, and then diamonds. Let's update our various suits. So we'll have spades, heart, and then diamond. So now for our tableau piles, what we'll do is we'll just sum this equal to an array that has 7 empty arrays. Alright, so next we'll need to reference these from our game scene. So what we'll do is we'll add a couple getters to go ahead and grab these various piles. And so we'll have get, we'll have our draw pile. Alright, so we'll go ahead and return this. We'll reference our deck, and we'll reference our draw pile. So I'm going to go ahead and copy this, and we're going to do our discard pile and then our tableau piles. And then we'll also do our foundation piles. So we'll change this to discard pile, update our reference. Now for our tableau piles. And so for this, will be an array of arrays. So we'll update our reference. And then we're going to have our foundation piles. And so for our foundation piles, let's go ahead and update our return type. It'll be an array of foundation piles. And so we'll go ahead and return. All right, so inside here, we'll go ahead and return our various foundation piles. So we'll go ahead and start with spades. Let's go ahead and do clubs, followed by hearts, and then we'll have diamonds. All right, so one other getter we're going to add is we're going to add a getter to checking to see if our game is actually won. And so what we'll do is we'll get, and we'll do one game. This is going to return a Boolean value. So to actually check to see if our game is won, what we'll do is we'll check each of our foundation piles just to make sure their value is set to 13. And if it is, that means the player's placed all of the cards, ace through king, in the various foundation piles. And so we'll go ahead and do return, and we're going to do this. We'll do our foundation pile club, we'll do our value, will be equal to 13. And now we'll do our other foundation piles. So now that we have our properties and our getters that we'll need for our class, we're going to start working on adding our logic for the methods that we previously added. And so we're going to go ahead and start with our new game method. And so for our new game method, it's going to be responsible for setting up all of our card piles in our game. And so to go ahead and do this, what we'll do is we're going to go ahead and reset our game state so that all of our card piles are empty. And that way we can go ahead and start new games if we want. And then we're going to go ahead and shuffle our deck of cards. Once we do this, we'll deal out our cards to our 7 tableau piles, and that way it'll match what we have laid out in our game scene. So our first card pile will have 1 card, second pile will have 2, 3, 4, and so on, up until we have our 7 card piles. So go ahead and do this. What we'll do is first let's go ahead and work on resetting our deck, and then we'll go ahead and reset all of our other piles. And so what we'll do is we'll reference our deck, we'll use our built-in reset method that we added. Next, for our tableau piles, we're just going to reset this back to an empty array. And so I'm going to just want to come up to our constructor. I'm just going to copy this here. Now we want to go ahead and reset our 4 foundation piles. And so what I'm going to do is I'm just going to copy this here. Go ahead and paste it. And then we'll go ahead and change this to reset. I'm going to copy this and also add that to each of our piles. All right, so next we just need to go ahead and fill out our tableau piles. And so for this, we'll use logic that is very similar to how we built these piles in our game scene. And so what we'll do is we'll do a for loop, and then we'll have an inner for loop for filling out the piles. So we'll do for let I equals 0, I is less than 7, I plus equals 1. So I'm just going to copy this. We'll go ahead and paste it, and we'll go ahead and change this to be j. So we'll do it for, we're going to let j equal I. If j is less than 7, then we're going to go ahead and increment it. So now what we'll do is we'll grab an instance of our card by drawing it from our deck. So we'll do const card will be equal to this, our deck. We're going to do draw, and we're going to go ahead and type this as a card because our deck should be full of cards. And now what we're going to go ahead and do is if this is the last card in our stack, we want to make sure we go ahead and flip it over. And so if j is equal to I, then we go ahead and flip our card. Now we want to go ahead and add these cards to our Tableau piles. And so we'll do our Tableau piles. And so for our index, we're going to go ahead and use our J index. And we're going to go ahead and do push. We'll push our card. All right, so next for our draw card method, when we draw a new card from our draw pile, basically what we want to do is we want to flip this card over and add it to the top of our discard pile. If we're not able to actually draw a card because our pile is empty, we'll go ahead and just return false since we're not able to draw a card. So to go ahead and do this, what I'm going to go ahead and do is I'm going to copy this here, where we go ahead and try to draw our card. I'm going to go ahead and paste it. What I'm going to do is I'm going to get rid of our type, and because it can be undefined now. And so if our card is actually undefined, we're going to go ahead and return false. If our card's not undefined, then what we want to do is we want to go ahead and flip it over. So we'll call our flip method on that card. And now we want to add it to our discard pile. So we'll go ahead and reference our deck, our discard pile. And we want to go ahead and push that card to that array. Then we'll go ahead and return true since we're able to draw a card. All right, so for our shuffle discard pile logic, the first thing we're going to do is we're actually going to make sure our draw pile is actually empty. If it's not empty, we'll return false, and we're not able to actually shuffle our deck yet. If it is empty, then we're going to go ahead and call that method on our deck instance. So what we'll go ahead and do is we're just going to add a safety guard. So we'll do if our deck, our draw pile, if our length does not equal 0, so we have cards remaining, we'll go ahead and return false. Otherwise, we'll go ahead and return true. And before we do that, we'll just reference our deck, and we'll call our shuffle in discard pile. And so what that's going to do is going to simulate us taking our discard pile, flipping it over, so we start drawing cards again. All right, so next up, we're going to focus on our two methods for being able to play our discard cards. And so when we play our discard cards, there's going to be two possible moves. We're either going to play a card to our foundation pile or to our Tableau pile. And the first thing we'll want to do is we want to make sure that the card that was played is actually valid. And if so, we want to add that card instance to that appropriate location in our Solitaire class. And so for this changes, we're going to focus on our play discard pile to foundation first. And so when we play a card from our discard pile to our foundation pile, we're going to want to do the following things. First, we want to go ahead and get a reference to the top card in our discard pile. And so what we'll go ahead and do is let's store that in a variable. Do const, we'll do card will be equal to our deck. And we want to go ahead and reference our discard pile. And now we need to grab the top card. So what we'll do is we're going to use the length of our discard pile. We'll go ahead and subtract 1. And that should give us the top card. And so if that card doesn't actually exist, so if our discard pile is empty, we want to go ahead and return false. And so if our card is undefined, we'll go ahead and return false. All right, so if our card's not undefined, the next thing we want to do is we want to check the appropriate foundation pile and make sure that this is the next card in that sequence. And so as an example, if I'm playing the 4 of spades to the foundation pile, I want to go ahead and check our foundation pile spade property and make sure that the current value is 3. And if it's not 3, we'll go ahead and return false. All right, so to go ahead and do this, we'll make a new private method. And so what we'll do is we'll do if not this is valid move to add card to foundation. And so for our method, we'll need to pass in the card that we're checking. We'll want to go ahead and return false. So now what we'll do is let's go ahead and add this method. And so we'll come to the bottom of our class, we'll add in our private method. And so we'll have our card, and it'll be, for our type, it'll be card. And this is going to return a Boolean value. And so what we're going to want to do is first, we want to go ahead and grab the relevant foundation pile. And so for this, we'll go ahead and use a switch statement. So we'll do let foundation pile. We'll type that to our foundation pile. Next, we'll go ahead and do a switch, and we're going to do our card suit. So now what we're going to want to do is we want to go through our 4 different card suits and then update our foundation pile to have the correct reference. And so we'll have case, let's do our card suit, and we'll go ahead and start with our clubs. And so if our card suit is clubs, then our foundation pile is going to be equal to our foundation pile club, and we can go ahead and break out of our switch statement. So then what I'm going to go ahead and do is we're going to go ahead and add our other piles. So I'm going to copy this, we'll go ahead and paste. So after clubs, we're going to go ahead and have spades. Then we'll have hearts followed by diamonds. Now let's update our references. And so we'll have our foundation pile spades, foundation pile hearts, and then foundation pile diamonds. And then we'll go ahead and add in our default case. And so for now, we're just gonna go ahead and do break. So now that we have a reference to our foundation pile, we just want to go ahead and check to see if the current card value is equal to our foundation pile plus 1. So we're going to do return card.value is equal to our foundation pile.value plus 1. Alright, so now let's go ahead and jump back up to our method. Alright, so if our card move is valid, then what we'll want to do is we'll actually want to move that card instance to that pile, and then we want to go ahead and remove it from our discard pile. And so to go ahead and do this, we're going to go ahead and make a new private method for adding the card to our foundation. And so we'll do this, and we'll do add card to foundation. And for our method, we'll need to go ahead and pass in our card instance. And now to remove it from our discard pile, we're going to reference our deck, our discard pile, and we'll do pop to go ahead and remove that from our array. Then we'll go ahead and return true, since it was a valid move. So now let's go ahead and add in this method. So what we'll do is come to the bottom of our class, go ahead and add in our method. Our card will be card. And so for this method, we won't return anything, so we'll just do void. So now what we want to do here is we just want to call the add card method on the relevant foundation pile. So what I'm going to go ahead and do is I'm just going to copy this code here. We're going to go ahead and paste it. And now we want to go ahead and for the relevant foundation pile, we call add card. All right, so real quick, one of the things you might notice is in our IntelliSense, we currently have an issue with our foundation piles. And what it's reporting is it's being used before it's actually assigned. And what's happening is in our code, because we're using our switch statement, we start off with our foundation pile being set to undefined. And if we ever reach our default statement here, then our variable will never be assigned, and now we're trying to access a property on it. And that's going to throw an error in our code, and that's not something we want. And so to protect against this, we need a way in our code to make sure that we cover all of our cases inside our switch statement, and for TypeScript to be aware of that. And so one way to do this is we can create a utility function that will make sure for whatever string we're trying to parse here, we cover all of our various edge cases. And if we ever reach this utility function, then we'll throw an error, and then that way we'd handle that elsewhere in our code. And ideally, we should never reach this util function that we add. And so to go ahead and do this, let's jump into our util files real quick. And so what we're going to do is let's export out a new function, and we're going to call this exhaustive guard. And so for this function, we're going to take one argument, and we're just going to call this value, and for the type, we'll set it equal to never. And for our return type, we'll also do never, and we'll come back to this in 1 second. And so all we're going to do in this function is we're just going to throw a new error. And so for this, we're just going to say error reach forbidden guard function with unexpected value. And so for our value, we're just going to go ahead and stringify whatever that value is. All right, so what we're doing here is basically we're just telling the TypeScript compiler that no argument should ever be passed to this function, and this function should never return a value. And so all it's going to be used for is for when we compile our TypeScript, it's going to ensure that we cover all of our bases here on our switch statement. And then that way we can avoid errors like this. And so to make use of our function, what we do is we get rid of our default break statement, and we replace this with our exhaustive guard, and now we pass in the same value that we used up here in our switch statement. And so what's going to happen is this is going to resolve the issue we had in our IntelliSense, and the reason for that is now we're covering all of our possible values for our card suit. And the reason for that is we have this currently typed to these 4 values, and we're covering them in our 4 cases. If this was just a regular string, so like if I type this as a string, then what's going to happen is now we don't have all of our edge cases covered because we don't have a default value here or any other case to handle these. But because it is static, because it is strictly typed to those 4 values, we do have it covered. And so as an example, if I get rid of our diamond suit here, we also have the same issue because diamond could end up reaching our exhaustive guard. And so now our code won't actually compile, and we need to handle it before we're able to run our code. And so this is just another safeguard that we can add to our code to be a little more defensive while we're programming. And so what I'm going to do is I'm going to copy that. And I'm also going to replace our default statement up here with our exhaustive guard. All right, so next up, we'll have our play discard pile to tableau method. And so what we're going to want to do is when we play a card from our discard pile to our tableau, the first thing we want to do is we want to make sure that we actually have a card in our discard pile. And so what I'm going to do is I'm going to copy this logic here. We grab a reference to that card, and we'll go ahead and paste that. And so next, what we'll need to do is we'll need to grab a reference to our target Tableau pile. And so to go ahead and do this, let's make a new variable. We'll do const, we'll do target Tableau pile. We're going to set that equal to this, our Tableau piles, and then we'll have our target Tableau pile index. And so now we're just going to add a safeguard. So if this pile doesn't exist, so if it's undefined, we'll go ahead and just return early. If our target Tableau pile is undefined, we'll go ahead and return false. And now what we want to do is, if we do have that pile, now we want to make sure it's a valid move for adding a card to our Tableau. And so for this, what we want to do is we want to make sure it's the next card in our sequence. And so as an example, let's say if our Tableau pile has the 5 of diamonds and we're trying to play the 4 of spades or 4 of clubs. And so for the next card, this would be valid because it has to be the opposite color and it has to be the next value when we're counting down. And so to do this check, we're also going to add this to a private method because we'll be using that similar logic for our other methods. And so what we'll do is we'll add our checks. We'll do if not this, and so we'll add a private method and we'll do is valid move to add card to Tableau. And so for this method, we'll need to go ahead and pass in the card we're trying to add and our target Tableau pile. And so if it's not valid, we want to go ahead and return false. If it is a valid move, now we want to go ahead and add this card from the discard pile to the target Tableau pile. And so what we'll do is first we'll start with our Tableau piles. We'll do our target Tableau pile index. Now we want to do push to go ahead and add in our card. And now from our discard pile, we can go ahead and remove it. So we'll reference our deck, our discard pile. Now we'll go ahead and call the pop method to go ahead and remove it. So now we need to go ahead and add in our new methods. Let's come to the bottom of our class. Let's go ahead and add in our private method. So for our card, we'll have our card type. And then for our Tableau pile, this will be a card array. And now we want to go ahead and return a Boolean value. So now to actually do our checks, we need to grab a reference to the last card in our stack of cards in our Tableau. So then that way we can make sure the card we're playing is the opposite color and it's the next card value that we expect. So to do that, let's add a new variable, do const last Tableau card. We're going to set it equal to our Tableau pile. And we'll go ahead and use our Tableau pile length to grab our last card. So we'll go ahead and subtract 1. All right, so now what we'll do is we'll go ahead and compare the color on our two cards, and if they're the same, we're going to go ahead and return false. And so we'll do if our last Tableau pile card color is equal to our card color, we want to go ahead and return false. All right, so next we'll want to check our card values. So what we'll do is we'll do if our last Tableau tile card, our value does not equal our card.value plus 1, then we'll go ahead and return false. And so in our example, if we're playing the 4 of clubs, then our card's value will be 4, and our last Tableau card value will be 5. And if we add 1 to it, since they're not, if they are equal, it'll be true, otherwise it'll be false. All right, so if it is valid, then we'll go ahead and return true. And so before we move on, we're going to want to cover a couple edge cases. So the first one we want to cover is if our Tableau pile is empty. So if we're trying to add a card to a stack where there's no cards currently, the only card that can go here will be a king. Any other value is not a valid move, and we want to show that. So to do this check, we're just going to reference our length on our Tableau pile. And so if our length is equal to 0, then we can only accept a king. And so to do that, we're just going to do our card value. And so if our card value is equal to 13, then it would be a valid move. If it's not equal to 13, it'd be invalid. The other check we want to go ahead and add is if our last card in our pile, if it's already an ace, no other cards can be added on top of it. And so what we're going to go ahead and do is we're just going to add a safeguard so we can return early. So after we grab our last Tableau card, so we'll do if our last Tableau card dot value is equal to 1, then we'll go ahead and return false because we can't add any additional cards. All right, so now we wrapped up our logic for our discard pile cards. Now we're going to go ahead and add in our logic for moving our Tableau pile cards around. And so for moving our cards, we have two cases. The first one is if we want to move a card from one pile to another, and then if we want to move a card to our foundation pile. And so what we're going to want to do is for both these checks, the first one we want to do is make sure that we actually have a card in that Tableau pile. And if not, we'll go ahead and just return early. If we do have a card, then we need to make sure that's the next valid card in that sequence. And so what we're going to do is we're going to start with moving our Tableau card to our foundation pile. And so what we'll do is let's go into our method here. So move Tableau card to foundation. Let's go ahead and make sure we actually have a card in our Tableau pile. So what we'll do is let's grab a reference to that Tableau pile first. And so what we're going to end up doing is we're going to do logic similar to what we did up here, where we grab our target Tableau pile and we make sure it actually exists. So let's just copy that block of code. We'll go ahead and paste it. And we'll go ahead and change this to Tableau pile index. And we'll go ahead and just change this to Tableau pile. So once we have our Tableau pile, we want to go ahead and grab a reference to the card, so the last card in our stack, and we want to make sure that actually exists as well. And so what I'm going to go ahead and do is I'm just going to copy this code here. We grab a reference to our card, and we'll go ahead and paste that below it. And so instead of referencing from our deck and our discard pile, we want to grab it from that Tableau pile. And so we'll do our Tableau pile. We want to grab our Tableau pile length and grab the last card. And so if the card is undefined, we'll go ahead and just return early. So now what we want to do is we want to make sure this is a valid move for adding this card to our foundation. So a very similar logic that we did up here, and when we played our discard pile to our foundation, we want to do this here. So we'll copy this block of code. Let's go ahead and paste it. And so if it is a valid move, we want to go ahead and add this card to our foundation and remove it from our Tableau pile from our array. And so what we're going to do is let's just copy this code here, and we'll go ahead and paste it. And so we'll add our card to our foundation, but instead of remove it from our discard pile, we just want to go ahead and remove it from the Tableau pile that we're currently referencing. All right, so next up, we have our move Tableau cards to another Tableau pile. All right, so in our method, the first thing we want to do is we want to go ahead and grab the provided Tableau pile index and the card index. We want to make sure that card is actually faced up to the player. So when our game starts, only the bottom card in our Tableau pile stacks is actually visible. And so if I try grabbing a card that's below it, that's face down, we shouldn't actually be able to move it around. And so if our card's not face up, we'll go ahead and just return early. So go ahead and start adding that check. The first thing we want to do is we need to grab a reference to our various Tableau piles, and we'll go ahead and store our reference to those. And so what we'll do first, we'll do initial Tableau pile. We'll set equal to this, our Tableau piles, and we'll use our initial Tableau pile index. Then we want to go ahead and grab our target Tableau pile. We'll set that equal to our Tableau piles, and we'll use our target Tableau pile index. And now what we want to do is make sure both of these exist. So if neither of them exist, we'll go ahead and just return early. So if our initial Tableau pile is undefined or our target Tableau pile is undefined, we'll go ahead and just return false. All right, so next we'll go ahead and grab a reference to the card that we're trying to move. And so to do that, we'll store that in a variable. Do const card is going to be equal our initial Tableau pile, and we'll go ahead and use our card index that was provided. And so if our card is undefined, so if we provide an invalid card index, we'll go ahead and just do return false. And so if our card does exist, now we add that check to make sure it's face up. So if our card is not face up, then we'll go ahead and return false. As if our card is face up, next we want to make sure it's actually a valid move. And so what we'll do is let's come up to our method where we added our discard pile to our Tableau. Let's copy this block of code here. And what we'll do is we'll go ahead and paste it here. And so what we're going to do is a valid move to add card to Tableau. So we'll have our card and our target, and then our target Tableau pile. So finally, if the move is valid, now we need to actually move our cards from one pile to another. And so if we grab just the bottom card, we're only going to move one card over. If we grab an index where there's more cards on top of it, we need to move all of those cards from that array, from that spot, to the next array. And so to go ahead and do this, we're going to go ahead and splice our array to grab the cards we need to move. So let's make a new variable. We'll do const, we'll do cards to move. We're going to set it equal to our initial Tableau pile. And so from this array, we'll use our splice method, and we'll go ahead and provide our card index of the card we want to move. So what this is going to do, it's going to go ahead and remove all cards starting at that point from our array and store it in a new array. So now what we can do is from our cards to move array, for each of our cards in this array, we'll go ahead and add them to our target Tableau pile. And so we'll use our push method to go ahead and add in those cards. All right, so for our last method, our flip top Tableau card method, what we want to go ahead and do is we want to go ahead and flip over the last card in our stack from our Tableau pile once we remove the last visible card. And so as an example, if I take this card here and move it over, what we want to go ahead and do is flip this card here so the player can start using it. And so to go ahead and do that, what we need to do is whatever Tableau pile index we provide, we just want to grab the last card in that stack. And if it's not face up, we want to go ahead and call our flip method on our card. And so what we're going to go ahead and do is let's grab a reference to our Tableau pile first. And so what I'm going to do is I'm going to come up here to copy a little bit of our code. So I'm going to copy this here. We grab a reference to our Tableau pile and a reference to our card. We'll go ahead and paste that in our method. So the first thing we're doing is grabbing our Tableau file based on the index. If it doesn't exist, we have our safeguard. Same thing with our card. So if there's no cards in there, we'll go ahead and just return early. And so if we do have a card, now we want to check to see if it's face up. So if our card is currently faced up, we don't need to do anything, and so we'll just do return false. If the card is not face up, now we want to go ahead and call our flip method. So then we flip it over, and we'll go ahead and return true because we did flip a card. All right, so those last changes, that actually wraps up our core logic for our Solitaire class. Alright, so those last changes, that actually wraps up our core logic for our Solitaire class. And so with the logic we have here, we should now be able to play a full game of Solitaire, but in order to actually see it in our game scene, we need to go ahead and update a few of our methods here to actually have the correct frame for our cards so we can play out our game. So to get started with these changes, let's go ahead and jump into our game scene, and the first method we're going to go ahead and take a look at is going to be our create draw pile. Alright, so currently in our event listener for our pointer down event, for when we click on our draw pile, we're just updating the frames in our discard pile to match our card back frame. Instead, what we're going to want to do now is first we're going to go ahead and add a safeguard to make sure we have no cards in either our draw or discard pile. If we don't have any cards available, we won't actually do anything. And so eventually we'll get to this state as we're moving all of the cards from our discard pile to our other piles in our game. And so next, we'll add a check to see if our draw pile is actually empty, and if it is, we'll need to shuffle back in our discard pile cards, and so this is where we'll start calling in our methods from our Solitaire class. Finally, if we do draw a new card, we need to update our discard pile card to actually have the correct frame based on the card we draw from our Solitaire class. So to get started with these changes, what we'll do is let's come down to our event handler for our pointer down event. And first, let's go ahead and do our safeguard. So what we'll do is we're going to go ahead and reference our Solitaire class. So if our Solitaire instance, if our draw pile dot length is equal to 0, and our Solitaire instance, our discard pile dot length is also equal to 0, then we want to go ahead and just return. We don't need to do anything with our click event. Next, we'll want to make sure if we have no cards in our draw pile, then we need to go ahead and do our shuffle logic. So what we'll do is we'll do if our Solitaire instance, our draw pile dot length is equal to 0. Now what we want to go ahead and do is we need to call our shuffle discard pile method. So we'll do this, our Solitaire shuffle discard pile. Next, we'll want to go ahead and update our game state to reflect this. And so we'll need to take all of our discard piles and we want to go ahead and make them not visible. So as we're drawing our cards, we make our card image game objects visible. We'll want to go ahead and hide these after we shuffle. And so to go ahead and do that, let's go ahead and reference our discard pile cards. And so for each of the cards in our array, we'll have our card. And we want to go ahead and just call the set visible method, and we'll go ahead and set them equal to false. All right, so then finally what we'll want to do is we'll need to update the state that represents our draw pile. So as we're drawing cards, eventually once we run out, there'll be no cards visible in our draw pile, and now we want to go ahead and update to actually show how many cards we currently have. And so what we'll do is we'll do this, let's call a private method, and we'll do show cards in draw pile. And then we'll go ahead and return early. And so what we'll do is let's go ahead and add this method to the bottom of our class. And so we won't return anything from this method. And for now, I'm just going to place a to-do and we'll come back to this. And so what we'll do is let's come back up to our code for our draw pile. All right, so what we'll want to do is if we do have cards we can draw, we want to go ahead and call our draw card method. And so we'll go ahead and do this. We'll do our Solitaire instance and we'll call our draw card method. After we do that, we're going to want to go ahead and update our draw pile. And so we're just going to do the same logic we did here. All right, and then after we do that, now we actually want to go ahead and update the frames on our cards. And so for our bottom card, we will just use the frame of our top card and we'll make it visible based on that top card as well. Next, for our top card, what we want to go ahead and do is we want to grab a reference to the top card in our discard pile and then use that frame for making this card visible. So what I'm going to do is I'm going to make a new variable, do const, card will be equal to this, our Solitaire instance, our discard pile, and now we want to grab our top card, so we'll use the length of this. So we'll do our discard pile length, and we'll subtract 1. And so now we have a reference to our card instance, and so instead of doing our card back frame, now we need to figure out which frame we need to use based on this card. And so to do that logic, we'll also make a new method, and so we'll do get card frame, and then we'll pass in our card instance. So what we'll do is let's copy that method, we'll come to the bottom of our code, and we'll add in that private method. And so for this, we want to return a number, which represents the frame we want to go ahead and add. All right, so for our argument, we'll select one argument. I'm just going to call this data. And so for this, it's going to be a card instance, or it's going to be a foundation pile. And so for this method, we're going to actually reuse it for when we're trying to update our frames and our foundation piles. And so we'll have two different types we'll need to support. And so what we're going to want to do for this method, all we're going to do is we're going to reference our suit frames variable. And so on this object, we'll pass in our suit that is on our variable that we pass in. So if it is a card or a foundation pile, we do have a property called suit. And so then that's going to grab that starting frame from our suit frames object. So then what we can do is now we can use the value property on our card or our foundation pile. Then we go ahead and subtract 1. And so what this is going to do is in our suit frames object, once we pass one of our suits, this will be our starting frame. And so let's say if I have the ace of clubs, because the value on our ace is 1, once we subtract 1, we'll go to our starting frame of 0. If I have the 5 of clubs, we would go ahead and start at index 0, so it's really 4 would be the index we want. All right, so then what we'll do is let's come back to our show cards and draw pile method. And so now what we want to do in this method is we want to just check to see how many cards we have available in our draw pile, and then we'll update the number of cards here to match that. And so basically if we have 2 cards in our draw pile, we only want 2 of these cards to be visible. If we have 1 card, we only want 1 card to be visible. If we have 3 or more, then we show all 3 cards. And so to go ahead and do that check, what we'll do is let's make a new variable, do const number of cards to show. We're going to set this equal to math.min. And so what we'll do is we'll reference our draw pile length. So let's grab our solitaire instance, our draw pile, and we'll grab our length property, and we'll compare it with 3. And so what this will do is which of these 2 is the minimum value, we'll use that. And so if we have 3 or more cards in our draw pile, then we'll choose 3. If we have 2 or 1 or 0, then we'll use that number. So now what we'll do is based on that number, we want to go ahead and use the setVisible method to hide our card. So what we'll do is let's reference our draw pile cards. And then for each of our cards, we'll have our card, and then we'll have our card index. All right, so what we'll do is we'll just use our card index, and we're going to compare that to the number of cards we have to show. And if it's less than that, then we'll go ahead and make it visible. So I'm just going to go ahead and make a variable. We'll do const, we'll do show card. And so we're going to set it equal to our card index if it's actually less than our number of cards to show. And then we'll do card, we'll do set visible, and it'll be based on show card. All right, so what we're doing here is because for our indexes, it's going to be 0, 1, and 2. If we have to show 1 card, we'd only want to show our index 0. If we want to show 2 cards, we want to show indexes 0 and 1. And so that's how our logic is working here. All right, so if we save our changes, we should be able to test our new draw card pile logic. And so as soon as we draw a card, we'll see right away that now our discard pile shows the card that we drew. And so we have our 4 of spades. If we draw our next card, we now have the king of clubs, and we see the card below it is our 4 of spades. If we do that again, now our bottom card should match our top card. And now if we keep drawing, what should happen is as we go through our cards, eventually we should get to the state where we remove a card. As soon as we remove that last card, now we have no more cards in our draw pile. As soon as we click one more time, our cards are now shuffled back in, and now our discard pile cards are empty. And if we draw our top card, we'll see our 4, and then we'll see our king again. Nice. All right, so next up, what we'll want to do is we'll need to update our logic from when we create our Tableau piles. So currently, when we create our cards, all of them are currently showing the back of our card. And what we're going to want to do is we're going to want to modify this logic to use our actual game state. And if our card is face up, then we'll use the appropriate frame. And we'll use that to determine if our card should be draggable. If our card is face down, then we won't actually allow it to be draggable. So what we'll do is let's jump down to our create Tableau piles method. And we're going to go ahead and update this to use more of our game state. And so we're not going to rely on our for loop here, where we do a hard code to 7. We're actually going to use the actual piles that exist on our Solitaire instance. And so what we'll do is after we create our Tableau containers, let's go ahead and update our for loop. And what we're going to do is we're going to reference our Solitaire instance. And we'll go ahead and grab our Tableau piles, and now we're going to go ahead and do for each. And so for each of our piles, we'll have a pile, and then we'll have our pile index. And now what we'll want to do is we'll go ahead and create our Tableau container and add that to our Tableau containers array. And so I'm just going to copy this logic here. We'll go ahead and paste it. But instead of using I, we want to go ahead and use our pile index. And so after we create that container, now we want to go ahead and create our card image game objects. And so instead of doing a for loop, we're going to go ahead and reference the pile that was provided. And so for each card in our pile, we'll use that to create our card. And so what we'll do is we'll do for each. And so in here, we'll have our card, and then we'll have our card index. And so now what we'll do is we want to go ahead and create our card game objects. We're just going to copy these lines of code here. We'll go ahead and paste it. And so now, instead of using J, we want to go ahead and use our card index from our inner loop. And then for here, we want to go ahead and use our card index and then our pile index. And so what we'll do is we'll go ahead and make them not draggable by default. And then we'll go ahead and add them to our container. Once we do that, we'll use the actual card instance, and we're going to see if that card's actually face up. If the card is face up, now we'll make it draggable, and we'll go ahead and update our frame. And so to make it draggable, we'll reference our input plugin, and then we'll call set draggable. And now we'll go ahead and pass in our existing phaser game object. So we'll do our card game object. And now to update our frame, we want to go ahead and do our card game object. We'll go ahead and call set frame. And now what we'll do is we'll use that method that we just created for getting that frame. And so we'll do this, get card frame, and we'll pass in our card instance. So then what we'll do is let's get rid of our other for loop here, since we should no longer need it. All right, so go ahead and save. Oh, it looks like we have an error. Yeah, so let's go ahead and come up to our create method. What we'll want to do is first, we need to make sure we actually have our Solitaire game instance before we call our methods for creating our game objects. And this is just because now we're referencing the state here. We need to make sure this exists. And so once we save, we should now see our game refreshes. And now in our Tableau piles, we now see our actual cards being visible. If we try moving one of our cards that are face down, we can't. But if we click one of our cards here, we can go ahead and move them around. All right, so for our next change, we need to go ahead and update some logic in our update card game objects in our discard pile method. So currently, when we go ahead and try to update our bottom card, we're just making it not visible when we run this logic. Instead, this needs to be based on our game state. And so what we're going to want to go ahead and do is let's go ahead and replace this code. We want to go ahead and grab a reference to our second to last discard pile card, and we'll use that to set our state. And so what we'll do is we'll do const, we'll do our discard pile card. We're going to set it equal to our Solitaire instance. Let's grab our discard pile, and now we want to go ahead and grab our length. We'll go ahead and grab our Solitaire instance, our discard pile, and we'll grab our length property, and we'll go ahead and subtract 2. And so this is going to give us the second to last card in the stack. And now we can do, if it's undefined, then we know this needs to be not visible. If it is defined, now we'll go ahead and update our frame. And so what we'll do is do if our discard pile card is undefined, we'll run our existing logic. Otherwise, we want to go ahead and make it visible, and we'll go ahead and update our frame. And so we'll go ahead and set visible to be true. And now we want to go ahead and update our frame, and so we'll do set frame. And we want this to use our method that we created. So this get card frame, and we'll pass in our discard pile card. And so if we go ahead and test this logic, let's go ahead and add a few cards to our discard pile until we find one we can play. All right, so if we go ahead and try moving our ace down to our, looks like we have a bug. If we jump over to our Solitaire instance, so in our play discard pile card to Tableau method, we return false at the end. This actually needs to be true. So let's go ahead and try doing another test. So let's find a card we can play to our Tableau. Okay, so we have this Knight of Hearts. If we play it, we now play it on top of our 10, and now we'll see that we have our 7 under our queen. Nice. All right, so next up, now we need to go ahead and update our foundation piles to actually show our card game objects frame when we add our card. And so what we'll go ahead and do is let's go to our method for we do our update foundation piles. And so right now we just have a to do. And so what we're going to want to do is we'll just want to update this based on our game state. So we're just going to reference our Solitaire instance. Let's grab our foundation piles. And now for each pile, let's go ahead and grab a reference to our pile. And so this will be our foundation pile. Then we'll have our pile index, and this will be a number. And now what we can do is if our pile's value is equal to 0, we don't actually need to do anything because we're not going to show any cards. And we'll have our background that we currently have. If the value does not equal 0, now we just want to go ahead and update our frame based on that value. And so we'll have our foundation pile cards. We'll pass in our pile index, and then we'll call set visible, and we'll go ahead and set this to be true. And now we want to go ahead and call set frame. And now for our frame, we'll go ahead and use our method, get card frame, and we'll go ahead and pass in our pile that we're currently iterating on. All right, so now if we can go ahead and find a card, we can play to one of our foundation piles. So now if we take our ace of spades, if we add it, we'll see our game state now updates to show our ace is now here. All right, so for our last code change, we just need to update our logic and our handle revealing new tableau cards method. So it's going to get rid of our to do. All right, so in this method, what we're going to want to do is we're going to want to check to see if we need to actually flip over the next card in our tableau pile that was just moved. To do this, we'll call our flip top tableau card method on our Solitaire class. And if we get back true, we know a card was flipped over. So now we need to go ahead and update our relevant image game object to have the correct frame. And we need to make it draggable as well because now the player can actually interact with it. So to go ahead and make these changes, what we'll do is let's go ahead and make a new variable, do const, and we'll do flip tableau card. We'll set it equal to this, our solitaire instance, and then we'll go ahead and call our flip top tableau card method. And so we'll go ahead and pass in our tableau pile index. And so if this is true, then we want to go ahead and do our logic. And so what we'll do is first, we need to go ahead and grab a reference to our tableau pile and then our tableau card from that pile. So do const, we'll do tableau pile is equal to our solitaire instance. We'll grab our tableau piles and we'll use our tableau pile index. Next for our card, we'll do tableau card is equal to our tableau pile, and when I grab that last card, we'll do our tableau pile dot length -1. All right, so now we have a reference to our card instance. We need to grab a reference to our phaser image game object. So let's make a new variable. We'll do const card game object is going to be equal to, we need to reference our tableau containers. And now we want to use our index so we can grab our correct container. And now we need to go ahead and use the getat method. And we know we're going to get back a phaser game objects image for our type. All right, and now we just need to go ahead and grab the last card from our container. And so what we'll do is we'll use our tableau pile dot length, and we'll go ahead and subtract 1. All right, so now we have a reference to our phaser image game object. We just need to go ahead and call set frame to update our frame. And so what we'll do is we'll do our card game object set frame, and now we'll go ahead and use our get card frame method. And we'll pass in our tableau card instance, so our actual card instance from our solitaire class, and that's going to give us our frame. And now we just need to go ahead and make our card draggable. So let's reference our input plugin. We're going to call the set draggable method, and now we can pass in our existing game object, and we'll pass in our card game object. All right, so with those last changes, we should now be able to test our game end to end. So what I'm going to go ahead and do is I'm going to turn off debug just so it's a little bit easier to see. And now what we should be able to do is if we try playing our card game, let's place our ace up on our foundation. Ooh, we'll do the same thing with our 2. We'll do our 3 and our 4. All right, so far so good. So if we keep playing, we should be able to finish up our game. All right, so with our core logic in place, the last thing we're going to do is we're going to work on making some UI improvements to our game. And so what we're going to do is we're going to go ahead and update our title scene so we have a nice splash screen to show the player when they land on our page. Then we're going to add in some transitions so that way we can transition smoothly to our game scene. So go ahead and do this. Let's jump over to our title scene. So let's comment out our code here where we go ahead and start our game scene right away. What should happen is now when our game refreshes, we should just see our gray background since we're still in our title scene. All right, so for our title scene, what we're going to end up doing is we're going to go ahead and update our background so it's black, and then we're going to go ahead and add in a couple of our images here to our scene. And so to get started, the first thing we'll do is let's go ahead and add in our image for our title. And to do this, we're going to go ahead and do this .add, and we'll do .image. This is going to allow us to add an image game object to our scene. And so for our X and Y position, we want this to be centered in our screen. And so to do that, we're going to reference our scale manager. And so by doing this, we can go ahead and grab the width of our current scene, and we'll be able to divide that by 2 to go ahead and grab our center point. Now for our height, is we're just going to do 100 pixels down from the top of our screen, and now we need our assets. So we're going to go ahead and use our title image asset, and we'll add that to our scene. So now right away, we should see our solitaire text appear in our scene. Now we want to go ahead and add our text to tell the player to go ahead and click somewhere in our scene to go ahead and start. So we'll add another image game object, and we're going to store this one in a variable. So do const, we're going to do click to start image, and I'm just going to go ahead and copy this here. Go ahead and paste it. And so now for our position, we're going to go ahead and center this as well. But then for our Y value, we're going to do 250. Now we're going to go ahead and update this to be click to start. Go ahead and save, and we should see our other image. And now what we want to do is when the player clicks somewhere in our scene, we want to go ahead and transition to our game scene. And so we'll basically do this logic here once we have that click event. What we need to do is we need to use our input manager, and we're going to go ahead and listen for input on it. And so we'll do this.input, and we'll do the once method. And so for this will be our phaser, our input, our events, and we want to go ahead and do pointer down. And so this will be our click event. And now when this happens, we'll go ahead and do our logic for starting our next scene. Let's just go ahead and take this. We'll move inside here. We'll get rid of our comment. Go ahead and save. All right, so now if we go ahead and click on our canvas element, we should be taken to our next scene. All right, so the last thing we'll do is let's go ahead and update our background. And so we're going to go ahead and do a black background. And so to do this, we're just going to go ahead and use a simple rectangle. And so we'll do that right above where we create our images. Let's do this.add, do rectangle. Now for our position, we want to be in the top left corner. Now we have to take up the full game scene. We'll use our scale manager. Let's go ahead and grab our width. We'll do the same thing for our height on our rectangle. And now for our color, we'll do 0x, 0, 0, 0, 0, 0, 0, and we'll do 1 for our fill alpha. So if we save, we should see our rectangles appearing, but we need to go ahead and update our origin. So for our origin, we're going to set origin, and let's go ahead and do 0 to do the top left corner. Much better. All right, so to make our game a little less static, what we're going to do is we're going to update our click to start image here to go ahead and flash slowly on our screen. And so to go ahead and create simple animations like this, we can create what's called a tween and phaser. And so a tween allows us to manipulate properties on our game object to be any value based on some type of duration and a type of ease. And tweens that we create are going to be stored in what's called the tween manager in phaser. And so one example of this is if we want to go ahead and animate our game object to move across your scene, we could go ahead and use a tween to go ahead and do this. We're going to update our X property to go ahead and move our object along our scene. And we can control this animation by setting the duration, so how long it would take to complete that animation. We can also do things like a delay if we want it to go ahead and wait before it starts moving. And so for our use case, we won't be doing our X property. Instead, we'll want to target our alpha property, and we go ahead and have it go between 0 and 1, so then that way it's not visible to visible. Then we'll go ahead and repeat that from 1 to 0, and then that way it kind of has this nice flashing effect. So go ahead and do this. What we're going to do is we're going to do this. We'll go ahead and do tweens, and this is going to reference our tween manager plugin. And on our tween manager, we can use the add method to go ahead and create a brand new tween, and then go ahead and add it to our manager. And so for the add method, this is going to expect a configuration object of the tween that we want to go ahead and build. And so for your tweens, the first thing we need to do is specify our targets of our tween. So what game objects do we want to modify? And so for this is going to be our click to start image that we created above. And then next, you need to go ahead and specify the properties that you want to go ahead and modify. So for our use case, we want to go ahead and modify our alpha property. And if, for example, I wanted to modify our Y property, we would do the same thing, we would just do Y. And so what phaser is going to do is when it gets this tween configuration, it's going to look for these properties, and depending on what properties are set, it's going to go ahead and modify those based on the configuration. And so when we specify our configuration for these properties, we can do one of two things. The first is we can just provide a value, and then what phaser will do is it's going to go ahead and start animating from whatever value it's currently at, and then animate to the value that we provide. And so if this was not visible, so if the alpha was set to 0 and we provide 1 here, then phaser would animate this from 0 to 1. Another way you can do this, you can do an object, then you can specify your fields, your start, your from, and your to field. And what this allows you to do is now you can manually set those values, and anytime this tween will start playing, it's going to go ahead and use the start and from fields to go ahead and start the animation from that position. And so we're going to go ahead and manually specify these this way. By saying our start and our from are at 1, that means our alpha will start at the value of 1, and we want to go ahead and animate it to the value of 0. And so this is going to give it the effect of having it fade out, so then that way it's transparent. Next, and specify a duration. So this is how long in milliseconds we want this animation to last for. And so we're just going to do 1,000. So it should take 1 second to do this animation. Then we're going to specify a repeat. And so what repeat allows you to do is you can specify the number of times you want this animation to repeat. And by doing -1, it'll repeat indefinitely. So if we go ahead and save, what we should see right away is now our screen, it starts flashing. And what's happening is our game object starts at 1 for our alpha, takes 1 second to get to 0, and then it automatically repeats and start doing our tween all over again. And so for your tween configuration, there are other properties you can go ahead and set. that allows you to do all kinds of different things. Like one example is you can introduce a delay between each of your repeating animations here, and you can create some really neat effects. One last thing we are going to do for our tween animation is we're going to add the yo-yo property. And what this will do is this will allow us to create a very smooth animation where it's going to animate from 1 to 0. And once it reaches the end, it's going to go ahead and play that animation back, but in reverse. So now we get this very nice effect here where it looks a little bit more slow. And we can see we're animating from 1 to 0, and then 0 to 1. Versus before, if we have this at false, which is the default value, we start at 1, we go to 0, and it repeats. And that's why we have that blinking effect like this. All right, so one last change we're going to make is we're going to go ahead and add a scene transition from our title scene to our game scene. And so currently, if the player clicks on our canvas element here, we automatically jump to our next scene, and it can be a little bit jarring. Instead, what we want to do is we want to introduce this nice fade effect, so that when we click, kind of have this fade out, and then when we go to our next scene, we'll have a fade in effect to complete our transition. And so we can do this relatively pretty easily with some of the built-in methods on our phaser camera object. And so what we're going to do is we're going to go ahead and update our logic here for our pointer down event to not start our scene right away, but instead we're going to go ahead and have that fade out transition. And so to go ahead and do this, what we're going to do is we're going to reference our cameras manager. So we'll do this.cameras. Next, we want to go ahead and grab our main camera. All right, so in Phaser, each scene has at least one camera, and generally this is called the main camera and stored on this property here. And your camera is the way in which all things are rendered to our canvas element, and it kind of renders out like what's visible to this camera. And so there's a bunch of different things you can do to your camera to create some really cool effects. Like you could zoom out, and that's going to make everything look smaller, as in your camera is like zooming away from your canvas element. You could zoom in, you can move it, you can have it follow game objects in your scene, and much more. But what's important for us is your cameras have some built-in special effects that we can utilize for creating these scene transitions. And the one we're going to go ahead and take a look at is going to be this fade out method. What this method allows us to do is create a fade out effect where we can specify our duration and the color that we like to use for our transition. And so in this method, what we'll do is we need to specify how long we want this effect to last for. So the number of milliseconds, we'll do 1 second. Next, we need to provide our color. And so your color is broken up into the RG and B, so red, green, and blue. And you can provide a value from 0 to 255. And so we're just going to go ahead and do 0, 0, 0. And so this is going to give us the color black. And then so next, we can specify an optional callback. And so this callback is going to be invoked for every frame of the animation effect that we're creating for the fade effect. And so for this, since it's being invoked a number of times, a few of the arguments that we're going to receive are, the first one is going to be the camera that the effect is being applied to. The next is going to be progress. And so progress is going to be a value between 0 and 1, reflecting how close we are to finishing this effect. And so what we want to do is we want to wait for our progress to be finished, and then we'll go ahead and transition to our next scene. And so what we'll do is we'll do an if statement. We'll say if our progress does not equal 1, then we just want to go ahead and return from our callback. Otherwise, we want to go ahead and start our scene. So now if we go ahead and save, what we should be able to do if we click our canvas element, we'll see now we have that nice fade out effect as we transition to our next scene. And so to complete our transition, we need to create a fade in effect on our game scene. And so go ahead and do that. Let's jump over to our game scene. And what we'll do is we'll come to the top of our create method, and we'll go ahead and create our fade effect. And so for this scene, we're just going to do and reference our cameras manager. Let's go ahead and use the main camera. And now we want to go ahead and do fade in. And so for this, we're just going to go ahead and specify 1000. So it'll be 1000 milliseconds for our fade in effect. And since we're skipping our RG and B, it's going to automatically default to doing black. And for this one, we don't need to wait until the transition is completed. We'll go ahead and have our code automatically run for us. So what we'll go ahead and do is now if we go ahead and click, we'll see we transition to our game scene. And we have this really nice fade effect happening now. All right, so with our scene transitions in place, the last thing we're gonna go ahead and do is we're gonna go ahead and update our background color for our game. And so currently our background color is this light gray color. We're just gonna change this to be a nice green color so it kind of matches old solitaire type games. And so what we'll go ahead and do is let's go into our main.ts file. And so here is where we specify our default background color for all of our scenes. And we're gonna go ahead and change this to 387F3C. So now if we go ahead and save, we should have our black on our title scene from our rectangle, and now we have our nice green color in our game scene. Alright, so with those last changes, that actually wraps up this tutorial. So as a reminder, there's a link in the description of the video to complete source code for this video, and as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video is released. For more great Phaser 3 content, please see the links on your screen now.